Team, we'll be closing the form in 2 minutes. Okay. All
or do I need the other mic? All of you can hear me well? So I'm back here again for the next set of this hackathon. I'm sure the last 48 hours and days before that has been quite fantastic, and you guys have been able to build something which is really remarkable. But now is the time to learn from some of the most amazing personalities in healthcare. And to start off, it's my pleasure to introduce Professor Anurag Agrawal. Professor Anurag Agrawal is a Dean of Biosciences and Health Research at Ashoka University. He's one of the most esteemed voice in health, not only in India, but globally as well. Graduated from AIMS, but then have done his work in research in many, many countries, including work with WHO as well. I find myself lucky to have introduced with Anurag sir. The conversation that me and Sankalp had once at Ashoka University was practically a mesmerizing experience for me, not only from the sort of a knowledge that he has around health, around technology, and how these are being combined together, but more importantly, his personality and the way he spoke about coming back to India, doing things, bringing India first, and so on and so forth. And I've seen that in many of these occasions whenever I had a chance to interact with you, sir. So you are shaping a lot in my personality. And I hope all of the young minds here who are building these amazing hacks will also learn from your experiences and your thoughts. It's glad to have you
Thank you
here.
very
Over to you,
much.
sir.
Very kind. It's been my pleasure to have met both of you at the time that I did. And it's always wonderful to see your journey. So today we'll speak about building health AI for India. My thanks to the organizers for allowing me to speak to all the young people in the room. And and this, by the way, is a plot that you should never copy because I generated from GPT 5.2 simply to make a point that I want to make. By and large, if you look at the world, you have to ask when we are talking about AI, health, India, how are we different? And one way to look at it is what is the need in a given nation for AI based solutions in health? If you have a shortage of doctors, you have a shortage of trained manpower, in today's time with generative AI, you're going to be looking for AI based solutions. It's not that other countries who want to do great advances in cancer, etc., will not, but the need for immediate AI applications in health will be far greater for countries that have need. And you can see that in this completely imaginary graph, there will be countries like Kenya, which is probably worse off than us, Brazil, perhaps a little worse, China, perhaps a little better. We all have high needs compared to the US and UK. Where we differ is in capacity. Now, India is unique that parts of India are comparable to the best places in the world. I mean, where you are sitting today, you are sitting in the middle of the best minds, the best infrastructure, the best people, the best opportunities. And yet, there'll be parts of India which are very heterogeneous, completely different from where you are, have tremendous need. The same is true for China, the same is true for some degree for Brazil, but is not necessarily true for Kenya. So, India, as being one of the largest democracies in the world, one of the very few places with high need and high capacity, must look at AI in health differently from the way US and UK would look at it, focusing primarily on high value applications, trying to solve problems of highly remunerative areas like cancer, brand new drug discovery. We really need to look differently. Many years ago, I was asked to write a paper for Science on bridging digital divides and how is India looking at digital health. And what you can see is that I wanted to tease out the difference between three words: digitization, digitalization, and digital transformation. Now, when you work primarily analog, just look at this possible health clinic over here. The doctor is looking at God knows how many patients together, all the usual concepts of privacy. How do we do this? All the ethical approvals we take for the type of research we do. None of it actually makes any sense whether you're looking at here as an outpatient or over here as an inpatient. These are real pictures of real Indian hospitals and outpatient clinics in villages. At most, this India, and I don't like to call this India Bharat and this India India. I mean, this is just all India or all Bharat, whichever way you like it. Analog is the way to go. Any attempts that we make to introduce digital AI, EHR systems over here are meaningless until we do a fundamental on the ground infrastructure transformation, or we come up with radical AI solutions like voice to data that make the life so much easier. But I'm personally very skeptical that with all these voices going on in the background, any of the well-proven things would easily work over there. But that's just make bigger challenge for us to solve. Now, on the other hand, this is also India. And this is a completely digitalized system where data is digital from the point of origin, can easily be stored, shared, organized without any problem. And when we come to ourselves as a nation, we actually have digital transformation around us. These days, when I travel abroad, I go almost anywhere outside India, it feels so primitive. I mean, payment is so difficult, things fail. I have to pay taxes in two countries, America as well as India. I mean, it's an absolute nightmare to try to do taxes in America compared to India. I mean, everything is so different. I think as a country, when it comes to think other than health, we have undergone a lot of digital transformation. In good parts of India, which are richer, we have gone a lot of digitalized stuff. But most of Indian health still is at this stage. And we need to think about this when we try to come up with AI solutions. So, what type of Indian health data ecosystem are we creating? It's almost impossible to dissociate any thinking on AI from thinking about the data ecosystem in which we live. On the left side, we have the stuff that we have done well. The Ayushman Bharat Digital Mission, it is primarily targeted at efficiencies. It's about enabling persons, even when we get to ABDM 2.0, which Eka Care is doing wonderfully, we will be enabling people, personal health records, citizen-centric digital data. That's lovely. That's ease of access. It may create transactional efficiency, supply chains, cost reductions. It's very good for needs assessment. It's very good for quality assurance. But there is a second side to this. That second side is how will you develop the future health systems, the type I said are of higher priority to countries that are high income, but this cannot be forgotten. How would you generate evidence? How would you do discovery? In fact, how would you do development, evaluation, implementation, re-evaluation of health AI? All this will not happen until we get beyond simply measuring efficiencies of the system towards the right-hand side. So data ecosystems, when you think about AI for India and building AI for India, need to be more than just scale. A typical thing that you will hear in most conversations is, oh, we have 1 billion people. Yes, we do. But the scale itself will not be sufficient unless we also get into detail. And its detail could be genome technologies, big biomedicine, P6 medicine. I won't get into details of it yet. But this kind of detail as well as scale is what China is doing well. If you look at the Chinese health AI strategy, particularly in data, they are creating massive cohorts. These massive cohorts are intensively studied, followed for long periods of time, built across an entire nation. And that kind of data generation is what will be required to get the maximum benefit out of AI. Now, in the West, you could think of UK. UK Biobank is a great example. Electronic health records within the NHS is something that UK, being a small country, can do very, very well. America, of course, is much more fragmented, but decades of EHR data allows them to do things for AI development that are not yet possible in India. And we have to ask ourselves, what is preventing us from doing it as we build the AI systems that are necessary? So what is happening in India right now? We have accepted the challenge of ensuring equity, representation, and quality. Gold standard datasets are being created under the MIDAS program that many of you may be aware of. And I believe that the speaker will be soon after me. And that's being led by ISC. Indian Council of Medical Research is leading the creation of medical datasets that will be made available to the community to ensure representation, equity in AI training. IIT Madras is leading Bhashini, IIT Bombay has led Bharat GPT. We understand that India being a multilingual country, there is no progress on capturing data well without also focusing on language. Another problem that has been with us, of course, when we think of building AI for India, is how to ensure access to data and compute to people. There is a very clear possibility that the people with the best ideas may not have the best access, and the people with the best access may not have the best ideas. And multiple competitions happen right now, and all of you probably have participated in India AI mission led initiatives, competitions, where people who succeed with their idea, even if they don't have access to data, can get access to both data and compute. And I would acknowledge that access to compute is still easier than access to data, and I'll come back to that a little while later. The last part is the corpus of knowledge. A corpus of knowledge containing the national guidelines, local inputs, SOPs in digital formats. For example, we are working with an organization called Pallium India uh, in the area of palliative care. I'll have a specific slide on that later. And we are trying to digitize a huge amount of their knowledge to create a local India knowledge corpus from what we already do in a format that becomes usable for AI models that can be trained. I'm going to go back in time to tell you a small experience, to tell you why I'm a bit negative on scale and much more positive on detail. Many years ago, we thought that India, being an import heavy country, was bringing in a lot of shipping containers. And these shipping containers were sitting idle, and we thought we could build electronic health centers, completely integrated data flows from the way the patient is seen to capture, fully digital, telemedicine capable on the cloud. And this was our first deployment in Kathal in Haryana. This is finished by now. And we did well. I mean, there was a lot of local enthusiasm. People came on board. Doctors started doing telemedicine. This was supported by CSR India and Hewlett Packard before it split into two. By 2019, we had e-health centers in every place listed on this map. The Asia Development Bank had taken us to Philippines, to Bhutan, to countries outside India as well. More than 1 million individual patients had been seen, and we had data for every visit. And we were really trying to see what could we do with the data. The challenge we ran into is all the data really told us was the quality of health services given in the type of villages where the e-health centers were being deployed was basically just poor. The diagnosis was the symptom. So you will have people with a diagnosis fever, diagnosis itch, treatments. Pretty much if you give me an anti-fever agent, take a paracetamol, maybe an aspirin, an antihistamine, some multivitamins, a few antibiotics, that was 90% of healthcare. What it taught me a very important lesson is that simply focusing on scale without strategic thinking about type of data, quality of data, who are we working with, is not going to make us a data-rich nation. And that is something that is going to be very important to all of you when you hear opportunities for simply taking something in 100 places versus doing, say, 7 to 8 places well. If you can select a smaller number of places capturing diversity and do it well, it will be far more powerful for you than hundreds of places not done well. And one of my favorite cartoon characters is Dilbert. And in this particular cartoon, I thought I would illustrate the point that wrong data is all around you. Yes, big data is about dealing with data of high volume, poor veracity, and all those things. But at the end of the day, there's only so much you can do with bad data. So you do have to work towards creating ecosystems where you can generate good data. Many times, the problem with bad data is you don't know it's bad. Or the biases in the data are such that either you don't think of them as biases or you do not know of them. It's a very famous paper, Obermeyer, about the same year we were doing those other things, that people showed that a particular algorithm, AI-based of course, used in America to predict which patients would become sicker and therefore require additional care was deeply flawed. So what you have on the x-axis is a score from the algorithm. What you have on the y-axis are the number of problems a person has, and the more the problems you have, the sicker you are. The purplish dark line are black people. The yellowish line are white people. And what you can see, for any given score, a black person will be sicker than a white person. And for roughly the same level of sickness, a black person will receive a smaller score than a white person. Now, if you examine the two possibilities that maybe black people don't get sick, well, that's clearly not true. They have shorter life expectancies. They have far more medical problems and complications. So you're left to know that this algorithm has a race bias. Do we think it was in the programmer? Some programmer decided to penalize the blacks? Of course not. The answer is very obvious. Society is biased. Poor people get access to healthcare with more difficulty than rich people, which means that if your algorithm assumes that all people just admitted are equally sick, then automatically it will normalize the greater sickness of poor people who had to struggle to get an admission. To those of you who remember the COVID-19 pandemic, I'm sure you would understand that if you went to a private expensive hospital, you would see patients with barely a cough, just some cough, a fever, just a COVID positive test. And if you went to an AIMS, you would see people on the verge of getting into ventilators. When you start merging data sets of very different heterogeneity, you need to be cognizant of the biases that are in the data so that you do not recapitulate them when you work on the AI. This has led many people, because data is difficult to get. Number two, you can work so much with synthetic data these days, and there are some spectacular successes. This is the Amy paper, Articulate Medical Intelligence Explorer from Google DeepMind, and this is Vivek Natarajan's work that recently came out in Nature. But here, using only synthetic conversations and nothing else, Amy the doctor spoke to Amy the patient, with Amy the critic making the conversation better, until the point that in a head-to-head comparison against a real human doctor, so real human doctor is in blue, Amy is in pink. What they're doing is they're looking at 100 objectively structured case exams with patient actors. The patient actor is rating them on openness, honesty, comfort, empathy. A third doctor is rating the conversation on correct escalation, correct management, correct diagnosis. And you can see Amy beats the human doctors on most things, particularly in empathy. Now, this is obviously true because when I went to train in America, the first thing they had to teach me was how to speak empathetically to patients, not how to be empathetic to patients, how to speak empathetically to patients. Because in India, you can learn to be rude and nobody really challenges you on it. Now, the problem with using synthetic data without enough real data is these models collapse. If you basically keep on generating synthetic data and don't put enough real data in it, you lose the tails. And once you lose the tails, you'll do fine in the common things, but you do badly on the uncommon things. And not to be cavalier, but I'll tell you this. Many people came out with AI apps using your phone to measure blood oxygen saturation. It was mostly right. When was it right? It was right when people were fine. Because when you are fine, there are only a few percentage changes in your oxygen. When was it wrong? It was wrong when the oxygen really fell. So it was wrong when you needed it to be right, and it was right when you did not need to know anything at all. So these kinds of things become a huge problem when your tails collapse because you use too much synthetic data. And India needs to find that balance between high quality data and enough synthetic data also to make it easy and be compliant with DPDP. And the reason we have DPDP is because of this. Another cartoon from Dilbert that, of course, as a computer person, as a researcher, we would love for huge data sets to be easily available to us and not have to go through a mountain load of paperwork to do it. But this is a reality that when people collect data, the motives for collecting data are not always the right ones. So, towards this, many years ago, I was part of a Lancet commission. You will recognize, well, the faces will come later. But the key question we were asking was looking at digital health, looking at AI, looking at big data. The key question is how do we go towards universal healthcare and a path that lets future generations flourish? And you will recognize some of the names over here. Certainly, Dr. Soumya Swaminathan is known to most of us in the room. My co-chair and lead, Professor Irna Kickbush, will be here also during the AI Summit. And many of these people, Ran Belisser, who leads the health system in Israel, was one of the biggest names in health AI in the world. And Ambassador Amandeep Gill from India is currently at the UN leading this entire digital envoy. These are the four things that were our recommendations. We have to look at the role of digital technology as a determinant of health. I think India does this very well. We have to build a governance architecture that fosters trust. I'll speak a bit on this. We have to govern health data to increase its public value. This is something that the AI Kosh was meant to do. Eka Care was one of the first companies to contribute to the AI Kosh, the wonderful work over there. Many more people need to get into the third area, as I've been saying, to do this. And last part, invest in the enablers of digital transformations. This is something where India is extremely strong. We are always thinking of investments into enablers of digital transformations. They may not necessarily be for health, but we can leverage them for health. So if we get 2 and 3 right, I think 1 and 4, we anyway do well. So what do you mean by governance that fosters trust? To me, there are only 2 parts: transparency and accountability. Now, in business, accountability is something that comes a double-edged sword. If you get something wrong, it can be trouble. But having accountability, make sure having consequences. Consequences is the 4 C's of accountability. One of them is consequences. It makes sure that people have trust. And transparency of intent, transparency of policy, and transparency of action are very obviously important. And these are things that we very specifically mentioned over there, that without transparency and accountability together, they will be very difficult to move forward in ecosystems. One part of what you would call transparency is going to be to know whether AI models work. Everybody who develops an AI model is in love with it. They think they have found something that's really going to change things. And those of us on the other side often find it doesn't. And I'll give you just one example. Retinopathy in diabetes is easy to diagnose by computer vision for a while now. But a systematic study to look at whether using it to diagnose diabetic retinopathy in a village makes any difference have been extremely negative. In a very large study with thousands of cases being screened, only 2 additional people got laser therapy for their eye. The reasons are too complex to discuss, but part of it is quality deteriorates as you go out to the field. Nothing functions as well as it does in the lab. And number 2, people who are likely to go with treatment will only do so if they are symptomatic, in case getting treatment is hard. And in India, getting further treatment is rarely easy if you're not rich. So for this reason alone, we have to create both a pull on the side of doctors, which is what we have to do, not you, that makes sure that people who are diagnosed actually get treated. And part of it is, of course, is knowing which one works. And this is work we are doing with Annie Hartley. It's a Gates Foundation investment at Ashoka. where we are working with locally tuned free models, and we are trying to create massively online open validation evaluation platform. It'll be called Praman when it is fully launched, perhaps around April or May of this year's. And this will allow us to recognize that not every solution will work for everyone, and people must determine what works for them using simulated cases to start with, and then real cases in a shadow trial mode later on. This needs to be done. And I'm very glad to say that we are working with EkaCare and many other people, quite our foundation in particular, to create the necessary engagement networks and co-developing regional language-based ambient AI layers. I mean, when I say we, actually Ashoka is doing very little, but we are working with all of you to make it happen. And we plan to do this in a way that's regionally scalable. And of course, another good point is better benchmarks. I would argue to you that the way benchmarking is typically done in the CS world is done to make it look good very often. So my colleague Suvrankar Datta, who's a radiologist, decided to go in the opposite direction with the radiology's last exam, where he decided to take in what is called spot cases. A spot case is something that in your exam as a radiologist, you are expected to get right. If you don't get it right, there will be consequences. But no information is provided other than the image, because you are expected, if you are a decent radiologist, to just look at the image and make a critical diagnosis. And what you can see is by not providing any information beyond a relevant image of a spot case, the performance of radiology's professionals was 80% plus, which you would expect. Even people who had just started was 50% or so. These are basically MBBS doctors. But before Gemini 3.0 Pro came, none of the other models got it right. And more or less what we could see is that a reasoning chain based analysis was critical to getting these things right. And there's a lot more that we need to do, even in what we think of as classical computer vision, to get better. And of course, we've been busy providing policy support to government and WHO, trying to create useful AI assistants for local problems. This is work done with AIMS for abdominal pain. So we have to pick up problems of local interest that doctors want support with. If no doctor wants your solution will not go far. Palliative care was one such example where everybody agrees there is a need for palliative care. Everybody knows that Indians are now living longer. People are not dying immediately, even with diseases like cancer. So we are having this long period where people require care at home and cannot keep running to doctors time and again, and need reasonable quality advice based on SOPs, but with a tremendous shortage of palliative care doctors. And again, I'm been a pleasure to have Sankalp visit us in our recent meeting. I already spoke to you about health data ecosystems. One in particular was the use of wearables for precision medicine, enhancing public data collection. And one of the things that I've noticed is young people like you in the room are where the solutions are. When we wanted to create a cheap smartwatch-based ecosystem on the cloud, completely compliant with DPDP, ability for people to stop their health data sharing. They may not want us to know why in the middle of night their heart rates were going up. I mean, there are privacy things, right? Even a smartwatch is telling us things about what was happening in the middle of night. And how do you turn it on, off, keep it, share it? And this project coordinate run by a couple of Ashoka undergrads now is a small startup they have created, telling us, you focus on the research, we will handle the data. I'm not telling you that this is great. I'm telling you this is good. We have good experience with it. But what I'm really trying to say is, give a problem to young people, something good comes out. And India has plenty of young people, as I can see sitting in the room. But here are the final, as I wind down, must solve problems for health AI to succeed. We need to get stakeholders aligned. Both sharing data and not sharing data contains risks. If we don't share Indian data, solutions will not work for us. If we let our data be exploited, we'll be sending out cheap data and buying expensive solutions. We definitely need transparency and open architecture so that we know what works. We need viable but not exploitative commercial models. We need explicit statements of intent and uncomfortable discussions on ethics. We need accountability. This is something we can't do without. We can have sandboxes, but there has to be a point after which you come out of the sandbox. There is going to be accountability even on the tech side. If the doctor is left accountable for everything, it's not going to happen. Then they will simply say, we are fine the way we are. We have to overcome an expertise gap in the workforce. Doctors are not very exposed to AI, nor do they know how to use AI. In fact, there are at least some studies, one in JAMA, where doctors using AI became worse because they did not know how to use it. We need public education. People will become consumers of health AI solution. They need to know more. And we need to preserve human agency. Just saying human in the loop doesn't matter. Human is not supposed to become a rubber stamp, not yet at least. While hallucinations remain reasonably high, you need humans in the loop in reality. And in India, there'll always be this question. There's a slide I borrowed from my wife, who's a radiologist. There are things that are easy for human and hard for human. There are things that are easy for AI and hard for AI. If something is good, easy for both humans and AI, it's really a cost and availability problem. If you don't have humans available in Northeast remote region, for example, but the digital signal works, data can move, perhaps AI is a solution. Inside a place where humans are readily available, you have to look at what is the cost of your AI solution effectiveness. One thing I'll tell you for certain, even what looks like a free solution is not free. There is a cost of deployment, there is a cost of running things that is very, very real. So free is not free when it comes to anything in this world. Then, of course, are things that are hard for both. These are also easy. Much of medicine falls in this category, hybrid. Human in the loop systems, both working together, is the only way forward. But I do want to say something. This quadrant of what is hard for human but easy for AI is an expanding quadrant. AI is becoming more and more capable of doing more and more things, and humans will, as AI comes in, start finding things hard. Already, we can see that remembering phone numbers has become very hard now. When we were younger, we had to remember phone numbers, right? I mean, these days I can barely remember three numbers, and if I lose my phone or gets discharged, I need to call my wife to find out every other number. And of course, is this one, which is easy for human, hard for AI, which is really something that is a good research problem for all of you guys and is scaling possible with human workforce. I'm going to end with this last slide, which has two messages at the same time, which is often what my talks seem to be. The first, I think, is the greatest danger of AI in health. In health is, on my words, that people conclude too early that they understand it. By and large, I think the word by Roger Penrose, where they said there is nothing called artificial intelligence, only artificial cleverness. And other words by other people who say that all generative AI prioritizes coherence over correctness. And where grounding is not possible, hallucinations are unavoidable. All those things are correct. But the second part, by the same person, is also equally important. Doubting is good, but not all doubts are rational. Because of our doubts, not to take up a transformational technology is as wrong as the top. So we need to go forward. We need to go forward carefully. We need to go forward transparently, and we need to be accountable for what we do. And thank you all very much. If we do it well, we'll have a better health ecosystem for India using AI. Thank you. Looks like I went a few minutes over time, Vikal.
Hello. Thank you, sir. This was quite inspiring, as always. But no, I think hackathon is all about that, going beyond and taking as much time. But if anyone has any question for Anurag, sir, I definitely have, but I don't want to take anybody else's thunder. So please, anyone, if you want to ask any question to Anurag, sir, please raise hands. So while people are thinking, sir, I really wanted to pick your brain on one thing. Uh, and when I go and listen to a lot of these podcasts and uh, what a very smart people talk about is AI will solve health, and health will be the biggest beneficiary of AI. And to an extent, that many of these conversations are that the diseases will end, sort of a thing, and bold statements such as cancer cure and all of that. So yeah, maybe like 2 cents from you, your research, and you've been into this. What's your views? Because as an
This is a great
individual,
question.
yeah, yeah.
Yeah, it's a great question. In fact, my science editorial that I wrote for them, I ended by pointing out you can do everything with AI for, monitoring a woman's health during pregnancy. But in the end, that baby still has to deliver in a very physical brick and mortar center. If the place where the woman will have to deliver is not there or is unhygienic or not in good shape, no amount of AI or predictive thing regarding saying who's going to have trouble will help. So health is unfortunately always going to end in a situation for everyone. It's like we're all dying just at different rates. Get us to a point where we are sick, infirm, and need physical treatment. There is no version of anything that AI can change that doesn't end in that. Which means ultimately health equity requires as much brick and mortar as it does AI and virtual. Now, what AI and virtual can do, it can keep you healthier longer. But there will be still the same number of people still falling sick at the end of the journey. And will we ever be able to completely cure cancer? Is almost impossible. So, see, what happens is it's ultimately a question of what kills you. Once upon a time, people died of heart attacks. We became good at treating heart attacks, so people started living longer. Before that, people used to die of infections. We developed antibiotics, people died of heart attacks. People now don't die of heart attacks, now to start having lung problems. Lungs, we don't know what to take care of yet. And given our pollution, lungs is going to be a problem. Then comes cancer and the brain, right? I mean, cancer gets you. We get better with cancer, we still have the problem of dementia. And all of you by now will have started seeing your elderly people that you knew develop dementia. So it's just, you get saved from one to move to another. I think what you can do best with AI is to make the journey easier on the patient side, the doctor side, without forgetting that in the end, it's brick infrastructure and people. And on the other side, keep people healthy for as long as you can and inculcate digital vaccines, good habits, early monitoring, early finding out. But yeah, health is not going to get suddenly changed by AI alone.
Anybody else? Any question? Great. Thank you so much, sir, for
Thank you.
being with us. This was inspiring, and thanks again. Yeah.
My pleasure. Bye bye.
Bye-bye. So, folks, after that inspiring talk from a doctor, now let's move to engineering. And I'm so glad to have Raghu Dharmaraju with us. It's pleasure, Raghu, to have you here. You should definitely go to YouTube, search for Raghu Dharmaraju, and listen to the podcast and many of these panel discussions that he has been. It's always amazing to listen to him. He's the CEO of Art Park in ISC, a national AI and robotics innovation lab. So all kinds of science stuff that happens over there. Works with deep tech startups, builds digital public goods, not only for India, but for the developing world, with over 2 decades of impact-focused innovation across global health, clean tech, and AI. He has also helped create a very prestigious institution called Vadhwani AI. So I think all of us would have not been thinking of AI since the time Raghu was practically working on that. My interactions with Raghu has always been super fun, engaging, and also full of edutainment, so to say. It was always amazing having to speak to you. The labs that you work on always inspires. The robots that you see in ISC, Art Park, etc. We are looking forward to having you here and speak to us and inspire the young folks. Thank you, Raghu.
You set too high a bar, Vikalp. Right now I have to live up to it. Right. How long have you folks been hacking on? For how long have they all been working on this?
It's been 48 hours.
For 48 hours. And I'm at the fag end of that. They just want to go home. So put Raghu in front of them, right? So
Everybody waits for the
yeah, right. Yes, yeah. Yeah, let me first tell you one thing, right? Hackathons are a great way to harness energy, and to see what all is possible, but it's certainly neither a validation of your technology or the market, right? I don't mean to talk down hackathons, but having been part of this, I've seen various types of journeys. There is this expectation that something from a hackathon will magically become some sort of a unicorn or something, right? And hackathon is just a beginning, right? Ahead of it lies lots of elbow grease, lots of heartbreak, right? Hopefully lots of perseverance, grit, 1,000 pivots, right? Before you finally do what the world wants you to do and you also enjoy doing and hopefully can make some money doing it, right? You have to bring all these things together, right? So with that, let me kind of just jump in a little bit regarding what we do and what motivates us, and hopefully you'll find some resonance in our work. I was introduced as an engineer. I don't think I have coded for 20 years now, right? I was an engineer a while ago, right? I have somehow meandered and made a career out of sitting between deep tech researchers of various tribes and markets of various kinds, right? And so I think the only skill left is talking some sort of high-level gyan. So let's see how I do that. So here, just for the title, are you... Yeah, actually this is, I'm a little bit more mobile that way, right? This is my slide changer, okay. Okay, yeah, the title I'm using is, we are certainly at a moment when AI is hyped more than ever, right? How many of you ate AI for your breakfast? How many of you are drinking AI, right? So I say until we can upload AI and, upload water and I don't know what the right word is to download poop or pee, right? Or maybe it's the other way around, right? We just have to realize that ultimately all we are doing is moving bits, right? Moving atoms physically and moving people really and metaphorically is where the action is, right? And AI can be a very important tool in that. And when you especially think of what you call the next 5 billion, right? Often companies have these strategies of next 1 billion. Next 1 billion means below the top 1 billion of the people, the next billion. Out of below that is actually the next 5 billion people, right? Who are not typically part of your regular commercial markets. How is AI really going to make a difference for them? And some of you might also recognize a pun in here, making AI count. You might remember early days of ChatGPT. Basic math wasn't that very easy for ChatGPT. That's when we came up with this thing of making AI count, right? So we consider ourselves as basically the innovation factory for next-gen AI and robotics. We work at the intersection of these three ecosystems: research and academia, startups and corporates, and of course, governments and nonprofit. Right? We do everything as mission mode innovation programs. We are not lab people, we are field people, right? So we do co-innovation and co-implementation. And ultimately, we are building innovations and startups for profit / nonprofit, and also building platforms such as facilities and data, right? So I won't spend too much time, but in this, ironically, AI-generated images, what you will see is 3 personas. The first persona actually are the people waiting to be taken care of, right? And you see the doctor is absent there and the nurse is like, what am I going to do? Right? This is often the situation in field setups, right? Especially in primary health centers. If you go out there, or now we have what we call Ayushman Bharat digital health centers, right? Administrators are dealing with all kinds of reporting. And the caregivers themselves, while they have to give care, caregivers came in with doctors, nurses. They have a dual role as an administrator and a caregiver, actually, right? They have to fill out forms, a zillion of them perhaps, right? Leaving very little time for the actual act of caregiving, or very little knowledge to actually do that effectively, right? And so there are many challenges in our health systems, right? So we came up with this vision 5 years ago, still very much in the shadow of COVID, pre-ChatGPT. And we articulated how exactly would various types of AI come together to make the journey for the common person out there. So this is a person we call Shanti. She wakes up in 2030 in somewhere remote rural India. She coughs, so she launches Sahayak, talks to Sahayak in whatever language that is she's comfortable in. And Sahayak listens to her, takes her permission, suggests certain other digital and bio tests, and based on the tests, contextual information and maybe health history, hopefully, ABDM consent-based health history. There's a low urgency score, but also what are the likely causes, right? Now, this was just a story that we made for the Lancet Commission for Reimagining India's Health System. After 5 years of effort, I've been one of the co-authors. It came out just this week, actually. And we use these stories to tell, often we get stuck on tech, administrators get very confused. How does it all come together? So the systems design is quite important, right? How does it all come together to ultimately make the journey easy for that common person? That's what matters, right? So out of this came 3 broad areas of our work: population scale, data, and AI. Think of this as stuff like, how many of you used to look for COVID predictions and all of that, right? You probably all logged on to covidindia.org at some point to look at the bubble map, see trend lines, and so forth, right? What happened after COVID? We forgot. What happened to all these folks who are doing disease modeling and epidemiology? What happens when the next pandemic hits? Which is, by the way, 50 times more likely now, given global warming and all of that, right? So in our lives, we will see maybe a couple more pandemics. So we started the population scale AI is a stream, which is broadly at climate and health. Individual level data and AI is what we typically think of as health AI. What do you do for one person, not about a population? And Gen AI and agents are really the base on which those two broad types of applications can be, can be built. But we actually imagined it in the pre-Gen AI era, right? We called it NLP. And really, if I were to just pick one reason for why there was this what we call like a graveyard of apps between 2010 and 2020, it is lazy, unempathetic design, right? Partly, a big part of it was technology, right? Voice AI was not ready. NLP generally was not ready to understand and give back coherent responses. But we don't have that excuse anymore. So let's see how we are going to do at the end of this hackathon. Right. So our current work, I'll just go through some of our work very quickly as examples, highlighting some key principles. Our current portfolio spans across dengue, heat health risks, livestock diseases, and environmental surveillance on the population scale work. Our individual level data and AI spans areas such as oral cancer. We also have an effort called Midas, which is about bringing together really use case driven quality data sets, right? And we also have Gen AI and conversational work. But really, I think what separates us is actually the stuff below. What am I looking at? Okay, there, right? So this is often the missed stuff, right? Which is working with the health systems closely, creating digital infrastructure. I say public/shared because public has a very specific definition. Shared, just if at least the key stakeholders have a certain shared infrastructure that goes a long way. And often the elephant in the room, and perhaps the biggest one without which all the tech can go to hell, right, is the policy and capacity. And that's underpinned by a very cross-functional team. So I was talking about COVID. This was Bangalore's COVID war room. I want to call out your attention to death one. That's how fast Bangalore set up its war room, right? Where does this war room exist today? Right. It's actually now integrated into a center in Bangalore called Integrated Command and Control Center that goes across. So Bangalore is one of the few cities that actually institutionalize some of this stuff, right? We were similarly involved in Mumbai. I was quite heartbroken, and actually one of the reasons why I came to Art Park to start some of these things was in November 2020, right? We all clapped, we said vaccinations are coming, and they said all this data science effort that you built can go home. Right? They gave us certificates. Right? Made me mad as hell, right? That why aren't we institutionalizing all of this data-driven capability that finally exists? And partly and that basically made, and now climate is also, this is not Gen AI image, these are unfortunately very real images in Bangalore, right? We asked, how do we really embed this data-driven decision making? And we started with dengue because it's vector-borne, it is climate sensitive, and it's endemic. It's everywhere and yet surprises public health folks all the time regarding where it shows up and how much. Right? So we now have, Karnataka is probably the only state in the country that has a dengue outbreak prediction system that is actually live. We predict dengue outbreaks 2 to 4 weeks out at a taluk level, right? Still a lot of work to do, but essentially it's not about predicting number of cases. Often working with the systems is important. If you go and ask them, what do you want? We want dengue case predictions. We realized that wasn't the point at all. We realized that all they needed was a spike from a baseline that was about 2 standard deviations out, and that gave them enough heads up to know where to take and what kind of actions to take. Right? So this way of working between the technologists and the system is hugely important, because the initial use case, they say, they don't understand the feasibility of that use case. Neither do they really understand what all AI could still do in a way that's useful. That requires close engagement, right? One thing I'll just call out here is our approach, especially on the health side, has been very DPG and DPI oriented. I don't know how ECA is seeing public health systems, especially where you're getting your revenues and such, right? I think the health stack and certain standards such as ABDM hopefully help private companies to serve government and public health systems too in a way that's useful. But that said, 70% of primary care in urban areas is anyway outside government systems, right? So I think we should think about this both. Often I advise new teams that are starting out saying, hey, we want to make a VC fundable startup. I said, then don't look at government systems, right? I'm not sure what the current latest experience is, right? Because the intersection between VC fundable startups and what you might call inclusive health, especially for the bottom 50% that has only 6% of India's wealth, right? It's very tenuous, right? Another fact, if you take all the big chains together in hospitals, they only serve to, their revenues, their market share is roughly only 3 to 4%. This I learned from Nachiket. I was shocked, right? So that's the fragmented market you're going after. I won't belabor a lot of these points, but a couple of things I'll say. You really have to think at the systems level and understand how your tech is going to integrate, right? Your AI is there, it's on a product or called by a product. That, along with the physical world systems that have to happen, is perhaps the real solution in health, right? And ultimately, all that has to work seamlessly. Like when you order a book on Amazon, right? Do you ever get a book recommendation that is out of stock to be shipped? Probably not. But it's entirely possible to get a medicine recommendation for medicines that are out of stock in a primary health center. Now, the difference is, as a PM or product manager, you are mostly dealing with mature digitized systems in the online world. But the moment you hit health systems, it's a very fragmented physical system, right? And unfortunately, there isn't like a global product manager for that is managing all of that so that, it works. So you have to think all bits. Outcomes come as a result of bunch of actions that are taken before the AI. There's a bunch of stuff that has to happen before the AI, a bunch of actions that have to happen in parallel, right? And evaluating each of these is important, right? So outcomes are things like actually how many people are getting better because of your solution. If your solution didn't exist, how many people wouldn't get better? These are very difficult quasi-statistical or RCT type stuff that is done to establish that, right? We know we cannot measure that often, rolling out technology solutions, but understanding this full chain will help you build AI that is actually useful. I might build an AI, claim 80%, 90% metrics on lab data or hospital-based data. The moment we have seen repeatedly, the moment you put it out in field settings, it doesn't work. Shouldn't we have taken field data to start with? What's the point of that gold standard data set if it doesn't help you understand its performance in field, right? So those are the sort of things that we should think of. Also, this is a simple framework we use, whether someone says, a lot of folks come to us and say, hey, we want to do AI for X. Is that AI for X a good idea? This is the framework, right? Impact potential, feasibility, necessity, full solution system design, acceptance usage, data. Data often will not exist, but at least can you bring it together in a reasonably economic way. Partners and of course scaling, right? This is a mental process. This is not linear. You of all people should absolutely understand this. This is usually a challenge more with the public health folks. They think we have this problem, you deliver the solution, and then we will test it and pilot it, right? In reality, it's loop-de-loop, right? You have a set of hypotheses you have. Those hypotheses are on problem definition, solution definition, the AI/ML use case, data, AI model, evaluations, all of that, right? And over time, you will improve your confidence in this through evidence on all of these. And these decisions are not independent decisions, they are interdependent decisions, right? So with that, I'll actually wrap up. We have some work going on with frontline health workers that we have done with Arman. A lot of work in actually figuring out what the exact solution was, because everyone says clinical decision support, right? It's not that simple. There are lots of challenges. We moved them back to more of a knowledge and on-the-job assistance kind of use case. That is now actually, there's plenty of behavior understanding through design research we did before we got into AI. Lots of Wizard of Oz experiments. And our evaluation looks at not just the AI, but does the AI actually understand the queries the way the user intended? And at the other end, is the answer actually useful, right? I don't know why this isn't working here. Let's see if, oh, sorry. Right, that's okay. We can skip that, right? So this currently is out. It's scaling across Telangana and big parts of UP. For us, the big deal is that we've brought down, that should actually say 14%, that last number. We brought down the number of queries that were going to medical officers by 86%. The satisfaction rates, both from the experts, who are human-in-loop experts for safety and accuracy, as well as the users, which are frontline health workers, it's above 95%, right? And getting to a 70%, 80% solution is, because of all the tools we have, I don't want to say super easy, but lots of people are getting there. It's from there starts the real hard work. Can you get to a 90% solution? Can you get to a 95% accurate solution? And can you make it stick? Are you seeing repeat usage, right? And for us, what's been very interesting is the queries length are getting longer. The length of the query, the number of questions are increasing, right? And these are the and this is very user-centered, right? And I think voice AI has a huge impact on this. We have code mixed and multimodal right now. And we are going towards where it should not matter actually. You don't have to specify the language. It will detect and switch as per what where you are, right? That's what we are going towards. We are also building this Kilkari is for those of perhaps largest mobile platform for mothers to get information. Still in IVR age, we are bringing that into the AI age, right? We also run Vani, one of the largest open source data initiatives supported by Google and really anchored at the Indian Institute of Science by Professor Prasanta Ghosh, right? So yeah, let me wrap up there. On health data, I won't say much, but there's a lot of DPG, DPI slides here. If there is just one thing I would say, keep use case in mind and work backwards before you say what data. Right? People often come and say, Raghu, we spent 1 year, we thought we had results, got on the field, didn't work. Right? Field is the lab. Right? So yeah, let me just stop there and back to audience. Thank you. Happy to take any questions or simply transition out. That's entirely fine because I know time-wise. I hope I have not convinced people not to get in the field and such. Is there anyone? They're all tired here.
Interesting question to ask you. And maybe, Sai, there is an overdose of health AI since last 48 hours, 50 hours for a lot of us here. And you work across the spectrum, and health is one of the verticals that obviously Art Park pushes in a lot. But then there are these amazing robots and on education and Vani. I mean, that project has helped us quite a lot as well. What's your favorite area, or what's where you see is the world is changing really fast and AI is making a lot of stride, or an area where you feel a lot more interesting to build innovations? And it could be health, but yeah.
I think health will always kind of remain like the pet topic, but health is also where I see the biggest gap between the promise and reality. It's just a tough nut to crack. I think a lot about education these days, because education is a space I think that, things are broken. Asha worker training is an obvious example, right? There's a huge churn. They have to, like, who remembers that stuff, right? And we give them some training and say, now you go fix people, the most difficult thing to do, right? So I think education and training broadly is an area that is really is changing, right? What's the role of humans? Can teachers become facilitators for self-driven learning? These are some of the things. Also excited about, I wouldn't say excited, I'm also spending a lot of time thinking about robotics and what it's doing to the manufacturing setup, because we've built 30 startups, by the way, right? A lot of it is things like drones, robotic arms, right? It's actually like a very challenging time for India, right? Because on one side, by the way, 40% of our jobs are MSME sector, right? This is not the big companies like Amazon or L&T. These are much smaller companies, anywhere between 5 crores to 500 crores. This is not very digitized. But for them to be competitive now, especially in the manufacturing sector, they have to automate. The moment you automate, what you are doing is, a lot of automation is essentially in our world removing friction, right? The friction comes from not so friendly government processes, not so intuitive government processes at one end, and the other end, friction of the physical world, right? And when all this is getting automated, what happens to this layer of people? It's a big conundrum. So on one side, we won't have the economic growth necessary without automation, but automation seems to imply reduction in jobs. It's in a country where we have huge differences already, where top 1% owns the 17% of wealth and the bottom 50% has 6% of wealth, right? Sorry, I didn't give you like a positive, I'm excited about this sort of thing, right? We are seeing very exciting stuff. Scientific foundation models, as a company we've built, was one of the 8 companies that won the India AI Mission's Foundation Model Challenge. And they are building scientific foundation models. So these are things like thermal analysis and CFD that goes behind your SolidWorks or ANSYS software that you might use for designing a building or designing an aircraft, right? It's a huge market. So that's one I'm very, finally one bit that I'm excited about, sorry.
Thank you so much. But yeah, I'm glad to hear that health is one of the most exciting topic for you as well. Awesome. Thank you.
All right, great. Thank you so much. I actually had a question for audience. Whenever audience don't ask me questions, how many of you have worked in health previously? Okay, all right. You are raising your hand kind of very reluctantly, like it's a sin, you want to admit it or don't, or do you not want to admit it? Okay, got it. How many of you have been to a primary health center that is at least 200 kilometers away from a city? Okay, all right. Cool. How many of you have ever sought care in a primary health center? Because Raunak, that was your only option? Yeah.
I think that was a good option with the amount of time that I had.
That you had. That was the only option. Yeah. Yeah.
I got to get my yellow fever vaccination done.
There you go. So some special situation, right? I think we have done equitable care when we are happy going to a primary health center run by government. Right? That's when we have achieved equitable care, right? So just encourage you all to just get out there, right? I'm sure you have built wonderful stuff, but get out there, let the rubber meet the road, right?
Thank you so much, sir. We just have a small token of appreciation for you. Sankalp, if you could please come up and give it to sir.
So from these inspiring words from Raghu and what keeps him excited and awake, we now move to another esteemed guest of ours, Surbhi Goyal. She is the COO of Quetta Foundation. Surbhi Goyal brings over 20 years of experience across finance, education, and digital health. At Quetta Foundation, she leads digital health initiatives, contributing to major national efforts, such as rollout of Ayushman Bharat Digital Mission and Quetta Center for Digital Oncology, etc. I mean, I have been able to speak to Surbhi at many, many occasions, and one of the things that I always take from you is this resilience and perseverance to solve the hard problems. And just some time ago, we were talking about health is not as easy as it seems. And on top of it, digital health needs a lot of grit. And the way you, Rizwan sir, Quetta Foundation are actually taking this baton far forward gives us strength as a startup, as entrepreneurs, to go forward and make it big in digital health. So looking forward to listening from you, Surbhi.
See my slides here? You know, while they put up the slides, I think the EkaCare team doesn't like me at all. To put me after Professor Anurag, and then Raghu means like, no, I don't know why I'm standing here, but I will try my best. You know, he said health is very hard, and you know, you must be wondering why a foundation, you know, somebody from some foundation has shown up to talk to you all. So just to cheer you up, you know, the founder of my foundation built a company around digital health, and it became India's 25th unicorn. So there's hope. Some of you may actually be able to build some solution and some organization, and then you can start a foundation and hire me. So, you know, that is also a possibility. Don't worry about it. I get very excited when I see EkaCare doing some really good work. You know, typically as a foundation, we don't often come and only meet with a particular organization, but I think they're doing stellar work. So thank you for having me, and thank you for hosting this hackathon as well. I'm going to talk to you about just something that we feel very passionate about. You know, so much innovation, right? We all spoke about, you know, I was coming from Mumbai this morning. I know exactly where I'm going to sit, what food is going to get served, you know, what time I'm going to land, etc. But now if I just fall off this stage, break my leg, I don't know which hospital, who's going to offer, which doctor, which treatment, right? So there's just so much that needs to be done. But it doesn't happen as much. Also because failure in healthcare has a lot of repercussions, right? It's not just like, oh, it's inconvenient. You know, people can die if you get it wrong. And it's very, very hard to solve for. And yet so many of you are here, right? Vikalp was telling me there were some 60, 70 teams that have applied, 12 will get shortlisted. So a lot of innovation is definitely happening in healthcare and faster than ever. But what that means is that we need guardrails. We need to have standards. We need to know how to build things, you know, by doing it right. And I think as a foundation, that's what we are striving for. So what do we mean by guardrails, right? There is patient safety at risk, like I mentioned. We may have a very cool AI tool, and I sometimes meet students and they're like, oh, it's working beautifully. We've tested it on almost 60 people. And I'm like, okay, so it's scary, right? When you start thinking that your tool is performing, but it's really not tested. And Professor Anurag spoke about that a lot. Data privacy, security risk. Now we have the DPDP Act. Those of you who may have seen it, there's a whole slide about 250 crore penalty and God knows whatever, right? So it's kind of a little bit scary, but we need to demystify it. Everybody wants to make their own solution, and I won't name the hospital, but it was a very interesting story. So my boss Rizwan, he was meeting this director of a very large cancer hospital, and he said, we really want to build our own electronic medical record. Rizwan looked at him and said, you're a oncologist. So if I get my IT team to read every single oncology paper and see YouTube videos and everything, will you let them perform a surgery? And he said, no, of course not. And he's saying, exactly. So therefore, you can't be building EMR as well. Your job is to be a doctor. So please be a doctor and make sure that you have the technology guys do, the work that they need to do. So I think just kind of everybody out there thinking that they can start making solutions is not really the way to do things. And of course, that means they are not interoperable. Too many questionable AI solutions. Sorry, I'm not trying to discourage, but it is what it is. And then, of course, lack of training, right? I mean, how many of us are being trained to be able to use some of these solutions? So, of course, what that means is that we need guardrails, right? We need to make sure that, there is clinical safety, there's data privacy, there are product standards, responsible AI standards, and, of course, building human capacity. Some of you in the room, Kiran is here. He's been very, very helpful with a lot of work that we do at the foundation. I think what we've done at Koita Foundation, we worked very closely with this organization. Some of you may not have heard of it because when Raghu said how many of you have worked in healthcare, not too many of you have, but there is a national body which accredits hospitals, right? So if you go into a hospital, typically you'll see a certificate which says it's certified. This kind of audit or certification would happen only for clinical, KPIs, right? So is there infection control, other doctors trained, etc. But we said if we really want to nudge India and the hospital system, then we also need to have standards for digital health for hospitals. And one of the things that we worked very closely with NABH was to start building those standards, which means hospitals actually start thinking of digital tools in their healthcare practice. We work, India has moved more and more from communicable to non-communicable diseases, and cancer and diabetes is a huge burden. Again, here the foundation has done a lot of work in defining workflows, KPIs, etc. I would urge all of you to read our foundation website, and gives a lot of work around it. We have actually 2 centers which focuses on digital health, one at IIT Bombay and the other one is at Ashoka. Very proud to share that we have almost 45 PhD students only working in digital health at IIT Bombay itself. So if any of you all have a problem statement, you all want to kind of, discuss with somebody, brainstorm, we could connect you also to our students over there who may be able to, talk to you about some of these solutions. Both these centers have also worked very recently with ICMR and WHO to put together that whole AI blueprint, which is going to be released next month in the AI Summit. And like a lot of people said, including Raghu and Professor Anurag, we need to really train our workforce. Again, a really quick story that has stayed with me. There was, Mrs. Arundhati Bhattacharya, who used to be the SBI chairperson. And she, I was reading her autobiography. I hope I remember her name right. But anyways, the story is that there was a bunch of senior bank managers who came to her, and said, everybody knows how to use a computer and the keyboard, etc. Humko to wo bhi nahi aata, and now you've got this bank software, and how are we going to actually use it? And we are embarrassed. So she actually had capacity building lessons for them at 7:30 in the morning before the bank branch started so that they could feel comfortable using a QWERTY keyboard, etc. So sometimes it's as simple as that, right? You have senior clinicians, consultants who are not only busy, but are just reluctant to admit that they don't know how to use some of these digital tools, and therefore capacity building, remains. So you may, some of you may make very cool tools, but you would be surprised कि use क्यों नहीं कर रहे, So it could sometimes just be that they're not comfortable using technology, and that's what it is. I'll just go through this very, very quickly. We also have 2 centers which are focused on, like I said, 2 disease conditions. One is cancer and the other is diabetes. Our center, think of them as the CTO arm of 300 cancer hospitals, right? Now imagine I'm a small hospital in Gwalior. I'm this enterprising doctor. I've done well for myself. I've made some money. I've got some money. And I've started this 50-bedded cancer hospital. Now suddenly you're telling me to make all these decisions, which risk pack solution to buy, which EMR to buy. What do? I don't know where to start, right? I can't go to Google and say best EMR solution and call 5 vendors. How do I do that? How do I make procurement decisions? So one of the things that is very important for us at the foundation is really defining the standards of what a good onco EMR would look like. And then pushing that out to folks like you who may want to build these solutions, and then go to NCG, say, hey, this is your playbook, and we are adhering to it, and therefore it becomes easier for that small doctor in Gwalior to make those solutions, right? So how do you standardize EMRs, etc.? I know a lot of you here are excited about AI, but eventually we will also need to have some standards in place as to how do you test AI solutions, right? Now tomorrow, 3 of you may be winners here, and you may come and pitch to me, and as a hospital, I'll be like, theek hai, you got this hackathon award, but how do I know your solution is good? What has it been tested against? What is that matrix, right? So more and more, we'll have to all collectively start working towards building evaluation models so that all of us have a fair level of playing. Similar work in diabetes. Here the problem is not complexity, it scales, so many, we are the diabetes capital of the world. Hospitals, doctors don't use simple clinic management software, right? So today, every time I go with my mother, her report is lost. She doesn't know what her HbA1c was, 3 months, 6 months ago. Very happy that EkaCare and so many others actually building robust clinic management software. But again, what are the standards? Again, what are we ensuring that these products are robust is something that we do at the foundation. Just one more example about interoperability. A lot of you may have seen those diabetes patch that people use now, the CGM devices which continuously monitor your glucose, for example, right? Now, the largest player, which is Abbott, they have their own software, right? So the data is getting captured on their own software. Meanwhile, there is a clinic management software which the hospital or the doctor is using, which doesn't talk to it. So now imagine if I'm a doctor and there are like SAB 25 people standing outside my door, and I have to open this Libra app, then I have to open my own app, and I'm like, chodo yaar, So how can we get these people to start talking to each other? Why are more and more solutions not interoperable, and how do you define standard? And that is actually the track that we as a foundation today are also sponsoring, is how do you get voice data products to start talking to EMR, because we think that this is extremely important. So, makes life easier for clinicians. So finally, and this is really my last slide, right? Because I would believe that in this room we have healthcare leaders, we have some startups, we have coders, researchers. Guardrails are important, standards are important, and this is because it reduces uncertainty, it reduces risk, it makes system interoperable. For startups, if you have a guidebook as to what is it that you need to build, instead of just meandering and figuring it out, it would be wonderful. You could go to the NABH website, you could look at what NCG is trying to do, so that you know exactly what to build, how to build, so that you can earn trust. And of course, for coders and researchers, healthcare cannot not just be some clever algorithms and some cute widgets that you build. It needs to have access to good quality data, structured data, clean data. all of it which is in clinical context. And this is sort of what we're trying to do at the foundation. I know that they said that sometime Aadhaar and UPI took as long as it did, but really that's the kind of revolution that we need in healthcare. And at the foundation, we're very optimistic that it'll happen someday. Wish you all the very best. Don't quit. Stay put in healthcare. Thank you.
Much Surbi. Surbi, if you can just wait here for a second. Can we please have Bhaskar sir to facilitate her? Felicitate, sorry.
Okay, for the moment everyone's been waiting for, before we get into announcing the final list of teams that have been selected to go forward to the final presentations, I would like to introduce and call our judges. So we have here Mr. Rohit M.A., founder of Cloud9 and managing partner of Peer Capital. So Rohit co-founded Cloud9 Group of Hospitals and helped scale it to India's leading maternity and women childcare health chain with over 40 centers and a revenue crossing over 1,200 crores. He's also the managing partner at Peer Capital, an early stage tech-native VC fund. Thank you so much for being here, Rohit. Please take your chair. We have with us Kiran Anandam Pillai, CEO and founder of iDrishti. Kiran has worked with digital public infrastructures in healthcare for a few years now. He's also in parallel, he's been working and he has founded iDrishti group of hospitals and eye clinic, eye group of hospitals, giving direct exposure to digital systems. And he's also helped in scaling one of few of the largest DPIs in India. So thank you for being here, Kiran. Please take your seat here. We have with us Abhishek Jain, CPTO at Swasth. Abhishek Jain is a technology leader with deep experience in building and scaling digital systems that bridge data, AI, and real-world workflows. At Swasth, he focuses on health tech innovation that drives interoperability and value in healthcare delivery. Thank you so much, Abhishek, for being here. Please take your seat. We also have with us Anubhav Jain, who's a senior startup investing manager at AWS. Thank you, Anubhav, for being here. We also have two of our judges joining online as they regret being here today in presence. We have Suhail Bidani, lead digital and AI, the Gates Foundation India. So Suhail leads the digital and AI portfolio at the Gates Foundation in India, focusing and leveraging technology to achieve equitable health and development outcomes. Thank you, Suhail, for being here. We have Rajiv Sikka, sir, Group CIO at Medanta Group of Hospitals. Rajiv Sikka is the Group CIO at Medanta. He's one of India's leading multi-super specialty hospital networks, where he leads digital transformation and IT operations across multiple locations. Thank you so much, sir, for being with us. Taking this forward, we would like to announce the top 10 teams for track 1. Can you send me the form? Who have been selected to present. So we have track 1. When we call out your name, please stand up. Tech devs. Med Synapse. Gray hairs. Strike Force. Yeah. Care Grid. I believe they're online. Yes, they're an online team. Console Terror. Interesting names. Care Pal. System Hang. Team Kubo Care. And Flexi Roasters. We also have Bokali and Describers. Congratulations, teams. And we have for track 2, 5 teams here with us. We have 2 Care. We have RVCNs. Meditech. Open Healthcare Network. And Scribbity-Dibbity-Doo. Congratulations again, teams. So in interest of time, we would like to start with Open Healthcare Network's presentation. Just a second, because they are having their flights. We want to start with their presentation at 6:30. So you want to. Yes. So Sankalp sir here will explain track 2 for the people who are not aware of what this track is and what we want to do with this particular element of this hackathon. Yeah.
Okay, thanks, Sam. Just a note for the judges. There are 2 tracks. Track 1 is Health AI on digital rails. It's a broad topic where there is literally no constraint. No constraint on whether to use Eka API or any API. Track 2 is primarily focusing on Scribe and EMR integration bit. And the idea is that, hey, can we standardize that sort of interoperability piece similar to, let's say, defining spec or protocol like MCP, and even going to an extent of standardizing the payload part of that protocol. So that's where track 2 presentations will focus on. I just wanted to sort of bring that to notice. Vikalp, if you want to add anything to that.
No, so I think fortunate to have Koita Foundation actually sponsor the track 2, and track 2 is quite important from fundamental digitization stack as well, because the idea is any EMR should be interoperability, work with any kind of a scribe utility, and there is a protocol which is an open protocol that has been defined, and these hacks are consuming these protocol. And this is like a starting point of the V2DD scribe capability. But eventually, this protocol should evolve more, such as we have protocols for LLM like MCP or for auth, etc. So these are 2 different tracks and 2 different awards. So I'm really looking forward for innovations in both the tracks, starting with Open Health. Yeah.
I want to briefly let you know the format of the presentation. There's a very strict timeline. We have 5 minutes for your presentations. There'll be a strict deadline. We will buzz you out after 5 minutes. There'll be a 2-minute question and answer session from the judges, and a 1 minute for the judges to deliberate, right? During which you can set up your next demo, right? We will let you know. Anything else?
Hello. Can we get started? Sure, sure. Can we? Hey everyone. My name is Bodhish. We represent Open Healthcare Network. With me, Jijin and Vignesh are here. So we are software developers by passion. We run an open source community called Open Healthcare Network, where we built an EMR that is now deployed in across 200 different critical care hospitals and around 1,200 primary health centers across India. So the thing that we were trying to do here, our focus was to build, like we already had a scribe tool and also Eka had a scribe tool. So how do we integrate the tool with our EMR and use the protocol that is developed by the VTD team? So what we've done here is, so just integrate the scribing tool into the UI. So on the UI, what you see is like a recorder, voice recorder. It can be like any kind of scribe front end that you can pull in. And just to like save time, let me just upload like this already filled encounter. So the idea is you send in an audio that can be transcribed by the scribing tool, and the results comes in the file format. And let me take a new patient here. Let me go to my encounters tab. I think it's Ritik. Yep. So I'll upload a 4-minute audio that is already talking about like everything that is required. So what I'll also just open the network tab. So what happens here is that the audio that gets uploaded is directly sent to the scribing tool. The scribing tool will process it in the shape that they have, and the output is generated on its own proprietary format that gets mapped to the Fire using there's a scribe to Fire SDK that was developed by the Eka team. We use it to like transpose the data from JSON to the Fire format. That will now again get sent to our backend, where the backend accepts it with the protocol, and it processes the data and sends the Fire back to us in front end. And once that is received, we send it back so that the data can be like inserted. It takes some time because it's a 4-minute audio, and also we are using some pro plan so that everything gets filled. So in like real world use case, this could be like really short when you use like a shorter LLM or a fine-tuned LLM based on the data. Backend, did it come? So this is the client side, and that's a server running there. It's only like 2 local devices connected over Tailscale right now. Oh. Okay. We got the response, and the patients got our data filled. The audio had the allergy fields for then acetaminophen was an allergic patient, and I think the note also what was sent was added. Then pollen was also an allergy that was recorded. Heart rate diagnosis, multiple diagnosis with its statuses and notes has been added in the system. Then what was the care plan suggested? Family member history, immunization history, procedure recommended, all of the data that comes through. Observation data also emitted based on the audio is coming here. Medicine prescribed also comes here. And the service request ordered for the patient also comes into the respective tab. So the responses are here, and this is like a high level overview of what comes through. And just to show you like a short demo, let's also try. The patient is sick. The diagnosis for the patient is fever. And yeah, let's send a short audio and see what happens. Oh, there is no audio, that's fine. Yeah. So the idea is take any patient, any format, you'll be able to like upload the video and get done with it. I think I have a recorded video of the previous session. Oh, that came in quickly. Did you see that? Oh yeah, diagnosis got added. So this is one way. Like what we can also technically do is that instead of like filling the data through the backend, we can like show it on the UI. Just to like save the time, we just append it through the backend. So the current tool that we have for scribing, it prompts the UI, and doctor will be able to pick what needs to be added. So there is a confirmation layer on top of it where you'll be able to. It doesn't support Fire right now, but that will be something we'll be able to like transpose and like get done. Thank you. You have questions?
Hello. Yeah. This is the care EMR, right? What
Yeah.
I'm seeing.
Yeah.
And the care EMR, was it already supporting FHIR in any other use case?
So fundamentally, all the resources that we have is Fire resources. So it is
So
like literally easy for us
natively
to
you
like,
had already kind of designed each of the sections that I see to support.
yes. So
Fire.
underneath we store the data with Fire R5. So this protocol also supports R5. So integration was like literally just mapping it to what we store internally. So it was quite easy for us to have do it.
Okay. But since you're working at that level, right?
Oh.
Suppose the EMR was not Fire native. What do you think would have been the challenge? And is Fire the best way to, in your mind, to get that transferred in?
So Fire,
From the scribe level.
yeah, technically, if it's not Fire, you are kind of like reinventing the same thing. At the end of the day, you will eventually build the same spec. Because healthcare is so complex, and Fire is the only place we have seen that the nuances are like built in, like addressed correctly. So every day when we have like around 100 deployments, 200 deployments, like everywhere people comes and ask for like a new feature. And that's already addressed in Fire. We don't have to like go reinvent and like build something else. It's already there. But for anyone else who's not having a Fire kind of front end, it'll be very hard for them to like show the nitty-gritty or like granularity of the data that you can like capture into. So for them, the eventual goal will be like fill it as like a text area, like fill the text area with like this op conditions or template or something like that, because they don't have these fields. So it's going to be hard for others, but yes, Fire will be like a good format. But the one feedback that I have for the entire protocol is to like add support for questionnaires, the Fire responses questionnaire, so that people who don't have like a full Fire format, they can just send in like text area for like 5 different fields that they generally use and get that text and fill it back. Don't need to like do a lot of token transformations for a larger payload in the Fire shape.
Also, just within Fire, there's sometimes mandatory fields versus non-mandatory fields, right? And let's say from a scribe output perspective, how did you guys handle if something that came in did not miss the mandatory field for you?
So for Fire, if you look at it, it's very hard to like miss a mandatory field because almost everything is optional. Yeah, encounter doesn't need anything. So I don't think like that will be the case in any scenario. But what the protocol also defines is like there is a there is like a scribe to Fire mapping. What it technically does is that they enforce like a different IG. Like you can think about it as like a US profile that's been defined for specifically for scribe, where the enforcement happens at the IG level itself. That's not there yet, but if that's built, the transformer itself will like validate and give the response back to the AI that, okay, dude, this field is missing. You need to like refill it and get sent back to us. But what we think is like it should be more agentic than like a one step, like just send the audio and back the response. It's never going to be like a practical use case like going forward, because we have like powerful LLMs coming in, and also you can like do with the smaller LLMs, you can do like transformations, like run an agent in parallel at a very fractional cost and use like a very big LLM for like larger context window. So if this is like if I'll be able to like say appointments, like one aspect that is supported. So for the appointment, if I am able to like also, if there is an appointment selected and that response comes back, if I'm able to send the available slots for the next 2 weeks and the LLM can pick it and like send it back, that'll be like quite nice. So I would say like just the protocol should think beyond just voice and also support multimodal inputs and parallel execution flow.
Thank you.
Yeah.
Time's up. Judges, you can use 1 minute for deliberation on scoring the teams. Again, just to kind of brief, 5 minutes for the demo, 2 minutes for the Q&A. We would also encourage the responses and the questions to be brief in the interest of time. You can start.
Good evening, everyone. My name is Bala Ganesh. I'm coming from 2Care. We are a healthcare startup here at Bangalore, developing a platform for oncology clinics and healthcare. So I'll just start off with the platform demo. Right now, so we are building the scribe to EMR 2Care. 2Care. The number 2. Yeah. So as the last person already explained, so the audio to scribe and scribe to FHIR part is already solved mostly. So I just want to explain how we solved the FHIR to EMR part. So basically, we are trying to build an adapter layer between inside the whole pipeline, where any user can pick any scribe of their choice. So right now, since Eka is providing all the platforms, we are choosing Eka scribes, where I'll just add in an audio file which is scribed from and conversation between a doctor and patient. So we can select any AMR platform, for example, EKACAS, where we'll just need to plug in our API so that we have access to doctor dashboard and all. So once the scribe and EMR is connected, all the pipelines will be already connected by the backend, and we start the pipeline. So how the pipeline runs is basically we use the same Python SDK package of converting scribe data into FHIR. So that's basically almost done. So how do we change FHIR data into AMR specific data? So when we submit a specific schema which EMR provider accepts for intaking the data which comes from FHIR or all the medical data, multiple AMRs have different schemas and stuff. So it's harder to integrate that part. So we thought of solving it from agentic perspective. So right now, the AI agents have all types of capabilities like scraping the web, reading through documentation, figuring out what schema it needs to take, figure out trial and error, human in the loop, everything. So we just designed an agentic structure which maps out what is exactly needed to be mapped from the FHIR data to the EMR, which has been provided. So basically, it just queries out different queries related to how it should gather information based on the documentation of the EMR, and scrapes all the documentation data, gathers a specific set of intermediate steps between comparing the FHIR bundle data, which has been a sample standardized information, and the EMR schema, and goes on a multiple loop from a prediction and self-critique loop, while the intermediate nodes will have a context regulator where it only concentrates on altering the data schema to align closely as much as possible with the FHIR data, so that we'll get a final mapping after multiple iterations. After that, dry testing will be done through the Postman APIs or multiple REST API endpoints, so that we get to know that the data final mapping which the agent has come across is perfectly matching the EMR's data points. So once that is done, So once that is done, the whole map pipeline will run, and we will get the whole data embedded or injected into the EMR. Like now, Eka scribe to Eka care is completely done, and the FHIR bundle is already visible in here. So this is okay if for an existing EMR and scribe integration. What if a new EMR needs to integrate it? So they just need to send us the documentation of what, let's say, OpenEMR or Open healthcare organization also. They'll just need to send out their documentation sites of how their EMR is going to integrate all those FHIR data or medical data. So our agent will take care of all those scraping, documentation, and coming up to a point of similar mapping, and give us the mapping. So we'll store the mapping and have humans evaluate it, validate it, so that it's very secure and authentication ready. And if there is any misalliance, because mostly the differences will come across when the optional fields are there, the required fields might not meet the requirement. So all those fields should be properly communicated by the agent. This is more of like a MCP server, which is not exposed to all the endpoints. So we'll have a specific set of mappings for each and every EMR, so that once this validation is done, all the fetch endpoints and get endpoints can be done through this adapter, through this process. So there, yeah. So that's basically the gist of it. Yeah.
This mapping that I'm seeing for OpenEMR, was this built by the agent automatically?
It provides to a certain level that few fields are mapping to a certain point. Then human in the loop can validate it and edit it accordingly. But yeah, so still this is prone to hallucinations, and this is not a perfect structure yet. But yeah.
What are the assumptions you made in doing this? I mean,
sorry?
Existence of documentation. You need postman collection and you need documentation.
Yeah, yeah.
If those two don't exist for an EMR, or if they do it in certain other way, then it's not doable.
Yeah.
Do you think database schema is a good replacement?
No.
I don't think so, because API endpoints anyway will require it for communication between two backends, right? So it seems seamless for any scribe or AMR to integrate it with the adapter.
And how are you qualifying the reasoning that's being done? I mean, by the postman collection at the end.
Yeah, so first we'll judge the schema selection by LLM as judge and self-critique with the loops alone. But after that, with the dry runs, we'll do the postman.
As a human, you are looking from the postman perspective that's succeeding.
No. Like the dry run will happen with the AI itself, but there will be relevant responses coming from the other end, right? API endpoints. So according to that, the agent will try to minimize, change the fields, change the schema, and write the proper data again. So.
How many EMRs have you tried this with?
2, actually. I didn't have that much time though. Sorry. Yeah.
Still, I think very interesting approach to actually create a very generic integrator into any EMR. I think lovely effort. Thank you.
Thank you so much.
Thank you, Care. We have next, Team Meditech from Tatwa Care. Please take the stage.
Hello. Hello everyone, my name is Kshitij, and yeah, sure, please. Yeah, take your time, note. This is track 2. Sorry. Meditech is my team name. My company name is Tatva Care. Shall I start? Okay, should I start? Yeah, awesome. Hello guys, my name is Kshatij. I'm from Tatva Care. We are going to present the team Meditech. So I'll just directly come to the solution, what problem we are solving. Imagine a case, it's 10:30 a.m. in the morning. A doctor has a pile of patients lined up outside his clinic. And obviously he has a smart EMR, he's a digitized EMR system, which he's been using. And when a patient comes, he interacts with the patient and then gets the details. And suddenly the next thing he has to do is, again, he has to point and click, go to the EMR, type the information, type the diagnosis, medicine. Every doctor has a different accent. Sometimes they mispronounce the name of the medicine, which again gets identified incorrectly in the EMR. Then he has to go and correct that name, right? So a lot of to and fro's happen in that EMR system. Now imagine that doctor is going to treat almost 20 to 30 patients in an hour. It gets a bit more difficult for him to again do this point and click things. What if we can find a solution which basically does not ask the doctor to do all of this manually? What if a system records all the things itself and creates the RX by itself? So this is what we have solved. We have introduced a voice RX feature. What it does is basically, there are two options a doctor has. Either doctor can choose to dictate, which means that after the consultation, he can dictate the complete summary, and then RX will be created. Another option is that there is an ambient mode as well, where a patient and a doctor are having a conversation. Doctor has switched on the ambient mode, and that doctor basically will take the consent from the patient to record this. The next thing he will be doing is to record the conversation between him and the patient, and once he closes, within a minute, he will be having an RX ready. Now one problem that we have solved, when I mentioned that there are a lot of different accents the doctor has, we have solved it in two ways. First, we basically have definitely put the ASR piece, where automatic speech recognition is there. Then we have trained our own med gamma model, which basically will identify the medicine and checks the closest match.
The patient is suffering for fever for the past 2 days. He also has
Let's have a demo.
headache and body ache, temperature 101, pulse 96, SpO2 98%. I am prescribing him Apoxil 1 tablet after food, Nivolumab 40 mg, Montec LC 1 tablet after food for 2 days, Paracetamol 650 mg before breakfast for 3 days.
Please note we have mentioned paracetamol. It's a wrong name.
Before breakfast for 2 days.
So digitization happens, and basically we identify what all.
Our RX pad has been loaded with the information. As we can see here, the medication is visible along with the dosage and the duration and the frequency. So over here I said Apoxil, but if I meant to say amoxicillin, and if I want, I can see for other alternatives.
So basically, if you see, there are two results that are being shown. One is obviously what is identified. The other one is, so basically this identified is what we have in our own database. The collection of database, we have around 4 to 5 lakhs of medicine that we get. But there are certain medicine that are recently launched or are still under trials, or maybe they are not live in the market yet. But somehow doctors have the option to basically provide that medicine to the user. In that case, EMR might not be ready. Our database might not be ready with that medicine. But again, our EMR will be ready, because what he'll do is, it will first search the DB. If in case he doesn't find that, it will search the internet as well. Although this medicine might not be immediately fulfilled at the pharmacy, but at least the EMR will have the correct recording of that medicine. So that's what we have done, so that all the medicine can be properly captured.
By hovering over the name of the medicine, and I can select the correct name I want, which is amoxicillin. So I'll select that simply. I said Nivolumab, and it has taken that correctly. I said Montec LC, and it has taken that correctly, but it is also suggesting me for alternate medications in case I want to change them. It has also taken the dosage and the duration correctly. I said paracetamol, and it has corrected that to paracetamol along with pantoprazole, and it has taken the dosage correctly. Now we'll go to end visit.
And voila, the RX is generated. So ideally the two major problems that we have solved. One is obviously saving the doctor's time, getting the whole RX piece by point and click. We have reduced that just one voiceover and everything is done. Second piece, we have solved the medicine identification problem. So that is also there so that patient and doctor both can avoid certain discrepancies while identifying an RX. So yeah, that's our solution. Thank you.
This scribe is not the Eka scribe. So I'm just a little confused on most of the other demos were about integrating and demonstrating with respect to FHIR, this one, right? So what is it that in this hackathon that you guys actually did is part of this?
Basically, we are a part of Tattva Care. We have our own EMR system called Tattva Practice. And this particular feature is integrated with our own EMR system. Although we have built the middle layer as well, so that it can be integrated with other EMRs as well.
No, we haven't used the scribe yet, but we have created in such a way that we can plug it into other EMR as well.
But when you're plugging in, what is the protocol under the hood that you plan to use?
Yeah, it's a FHIR.
So even you produce FHIR as an output?
Yeah, definitely.
Okay.
We have the FHIR bundle library up our own. We have recently. But you don't use the No, not yet. Yeah.
Okay. And your UI itself, again, all of the elements that I saw, that's all FHIR native. Does it align well with the FHIR resources or
no,
it doesn't?
It doesn't. The FHIR will be only backend perspective, right? So it will be only act as a backend part, not on the front end. Front end will use a JSON format. That's what we're getting from the LLM and the pipeline.
But then you will need a conversion, no? So in between?
Yeah, we'll do the conversion from JSON to FHIR, and then FHIR will pass into that respect to EMR softwares.
Okay.
Sorry, that's already done, or that's already done? What you just explained?
This is in our pipeline. The application is already live, and we have some thousands plus doctors who are actually using
not your own. The middleware that you're
middleware, it's not live yet.
It's not done yet.
Say if the problem statement was that you would have to use Eka's scribe and then have that data go into your Tattva EMR.
Yeah.
How complex would that be in your current system or architecture?
So we'll use the same logic that we had. We'll converting our JSON into FHIR, right? So we'll convert that FHIR into our JSON format and we'll integrate with your UI components.
Okay. Any recommendations for how that protocol could improve based on what you've seen here in the hackathon?
Actually, I've gone through the documentation, but we have not deep dive into it. We need to fix it.
So ideally, what we thought was that we can integrate with any EMR system. We did not actually put the scribe in focus. So that was a miss from our end, definitely. But yeah.
But B2DD as a protocol is not in the focus, right? I mean, it's completely off. But all you're saying is like B2DD produces FHIR, you also produce FHIR.
Yeah, definitely.
That's all I'm
Yes.
Yeah.
Yes.
Thank you, guys.
Thank you.
Thank you.
Also, just want to mention, Raji sir and Suhail sir, please, if you have any questions, please do raise your hands here. Next up, we have team RVCNs for presenting the track 2, please. Guys?
I get a chapter also?
Good morning, everyone. So let's start with the context. So how many of you know ASHA workers over here? Yeah, so we are Team RVCNs. We are a group of students. Yes. So yeah, starting with the context. So how many of people of you know ASHA workers here? So just to enlighten you about whoever doesn't know, actually we should be knowing. So these people or health activists are basically covering our rural problems, cases of medical, all medical cases of these rural landscape and connect the government to them via last mile healthcare facilities. So what they do is basically they go home to home, along with the nurse, give them basic vaccination, treatment, whatever is required, and gives them basic medical advices. After that, they are basically last mile to cover what these primary health centers at the rural level. So what is the problem we are actually trying to do? So these ASHA workers are basically uneducated people who actually join these forces just to get incentives mostly. So what happens is basically since they want to be trained. So what the problem with this is, most of the documentation isn't done. And along with that, let's take a case that a person who is earlier going with they have a case where they go early to primary health center. Now, if the case magnifies, they go further to government hospitals. But let's say there's no documentation at the first level from these ASHA workers because they are not well trained on. So what happens is, again, there's a redundancy, there's no documentation, and then these medical records are not noted for these people. And again, they go to the next level of your government hospital where there's no track record of the historical records. So what we are trying to solve is this structured documentation layer between these ASHA workers and the last mile rural people. Yeah, so. Yeah, you can move directly to the first one.
So the problem boils down to data being unstructured, and that prevents us from taking any informative insights based on the data that is actually very valuable. Let's directly get into the prototype. So we have made an Android app basically,
Quick
which
question: what are they using?
And we can directly save it in.
Do you know what are they using today? Because
Format.
you said data is all over the place.
Yes,
Is there any digital form of collection of data or?
No, currently it is entirely by paper.
Right.
So they maintain books. So it is entirely offline. So they tend to lose records. Though they are doing so much of work, they're putting in so much of effort and so much of time. All of the data is stored in books, and that can't be translated into something useful.
That entire history and knowledge is not transferable.
Correct. So that's where we plan to use Scribe and EMR integration. So Scribe allows ASHA workers to record their conversation with the village people. So while ASHA workers do visit every house, they can record their conversation with the person, and that can be translated into a structured FHIR document. So what we have done here is we have taken first converted into FHIR document. That FHIR is then put into EMR, here in this case ECA EMR itself, via integration adapter. So mapping of fields had to be done to make sure that in any case, not only EMR or ICA scribe, any scribe and any EMR, irrespective of it, this integration adapter would allow us to map the fields to that. So this revolutionizes the whole concept of unstructured data being now structured, by which we can take better decisions of preventive healthcare and so much more.
Yeah, so moving on to the main demo part. So let's start with.
Yeah, so I have been facing nausea, insomnia, vomiting, and anxiety at this moment. So that would go. There are two aspects to this. This is a web version wherein ICA provides a lot more libraries to work with and languages to work with. The Android version had only 2 languages to work with. So it would be better if we are looking forward to integrate more multilingual capabilities into the Android app itself for better accessibility.
Should I continue? If I'm fine to continue, I can continue. So basically, we designed it into 2 layers. The first one is the mobile app, which we target to ASHA workers, since most of these carry phones and definitely not laptops. So they carry these to your rural, all those homes, and then they get transcription, and directly that connection goes to the EMR. Now the second layer, the web application, is where we are trying to target your primary health centers with the little better bandwidth, so that so basically in this also we have got 2 layers. One is your normal, your scribe to your EMR integration, and we designed the custom connectors. So basically this custom connectors connect to your R5 bundles to your ECA EMR layer, while your apart on top of this, we have actually tried to build an AI triage layer. So basically, as I told, the way ASHA workers actually do the diagnosis is unstructured. So basically, most of them are not trained on. So what we try to do is, okay, let's say in primary health centers, we have a better bandwidth. So we are trying to take your help of your gamma models to conduct their own AI triage model. So yeah, if you want, go ahead.
So I've been facing nausea, insomnia, anxiety, and paranoid at this point of time.
I understand this is very distressing. Are you feeling like you are in immediate danger to yourself or anyone else right now?
मुझे इस समय बहुत डर लग रहा है. क्या आप कुछ कर सकते हो?
मुझे माफ करना कि आप इतने डर में हैं. क्या आपको लग रहा है कि कोई आपका पीछा कर रहा है, या क्या आप ऐसी चीजें सुन या देख रहे हैं जो दूसरों को नहीं?
This was just a demonstration of what we wanted to build, that ASHA workers need better prompts to ask the village or the patients that they are dealing with. So usually they have a very one standard format which they apply to every patient, which is not, we are missing out on a lot of important data. But if we have a live triage, which we hope to build more advancedly, so they'll have real-time transcription. With that, they can ask better questions, allows for better data collection.
Guys, I think that's time up. We'll leave it to the judges for the questions.
Clarification, so you are trying to solve for better question to be asked, which can then translate to more information capturing and therefore translating to better diagnosis. Is that what you're trying?
So the main idea is to first to document. On top of that, that documentation also leads to a better structured diagnosis. That's the idea. So the first one, the main MVP is your scribe to FHI and then EMR layer. On top of that, we are trying to build that AI triage models for better diagnosis. That's all.
Second one doesn't use scribe, right?
No, sir. That's our own your gamma models.
First one you use scribe.
Yes.
Where did you get the D-dash the IDs from?
Which one? So for this we have, you mean just the raw JSON, right? One second, sir. You mean in this layer? Okay. So basically, we have actually, if you have found it, so basically we have first tried to use Eka Scribe, your Python SDK. On top of that, that goes basically to scribe to file bundle, and then it goes with our custom adapter back to your this Eka EMR layer.
So the fields are part of the FHR bundle.
Sohail, please go ahead. Yeah?
Sorry, I couldn't hear the question clearly, so I'm requesting Abhishek or whoever else to use the mic. I actually have a couple of comments and not necessarily a question. One, I want to first of all acknowledge that, okay, great, your target user is great. I'm not sure if the use case is correct because Asha does not do a diagnosis per se, right? Her role is more of a facilitator, intermediary in between. So that's just one correction. Second thing, I do want to highlight one quick thing. You said they're not uneducated. There's a qualifying criteria. No, actually, there's a criteria. Everybody has to be 8 plus at least or 10th in some states.
I thought it was 12.
I'll say not uneducated, but limited. And they have been given limited education till 10th.
Fair enough. I do want to encourage you to start thinking on how the same thing could be applied from efficiency perspective of actually filling these applications that they use today. They do use multiple applications. How can we use Scribe effectively to bring more efficiency? That's the only suggestion I have, minus the diagnosis part. I'll pause.
Yes, sir. So any more questions?
I did in your mental model. Yes. Where was the EMR going to be running in your scenario? So the mobile app was Asha.
Yes,
so where was the EMR supposed to be running in your mental model?
The EMR is supposed to be a desktop app itself.
Yeah, but who's using it and where was it running?
So the primary healthcare centers are using it.
Okay.
Where they can see the total number of patients and the visits, the schedule.
Okay. No, thank you. I was just wanting to be sure that that's what you're thinking about.
Yes.
Okay. Thanks. Nice. Good job. But yes, I think Suhail's points are quite valid in terms of how you understand or think about the user.
Yes.
Right. Thank you.
Thank you, team. Next up, we have team Scribbity Dibbity Doo. Spelled SCRIB. Yes, this is the last of the track 2. Yeah. Post this, we'll collect your responses for the track 2 teams. Yeah.
Hi, we are team Scribity Diabity Do. I am Sanika Goyal. He is Vicky Kumar. Today we are presenting our solution, MedScribe Alliance Extension. One solution, any scribe, any EMR. Over.
Okay. The healthcare ecosystem faces the major challenges, basically N into M integration explosion. Uh, so I'll slide it. Yeah. So every EMR and every scribe providers are basically integrated with each other with a custom integrations that they had to manage. Each integration is built separately. They have different APIs, different data formats, and there's no common standard. So, and this leads to high development cost, high maintenance, and limited choices, which is with this low innovation. So, because nothing is standardized, every new integration become expensive and time consuming. So EgaCare is already have taken a first step in doing the standardizing these solutions. So how Scribe backend APIs should be and how EMR should consume the data, and standard front and back end communication between the Scribe providers and EMR providers with the protocol. Based on that, we have built our solution, Metascribe Alliance extension. Our SDK, which is act as a universal bridge between scribe providers and EMR providers. I'll start with this diagram. Okay. So there could be multiple scribe providers in the market, and there could be multiple EMR providers basically. So we have built SDK, which is following the Metascribe Alliance protocol, and EgaCare already have deployed their backend based on the protocol Metascribe Alliance. Following that protocol, our SDK can be plugged into any a scribe and any EMR. Each EMR need to write their own adapter to consume the data in which format they want to accept. The scribe providers will respond the FHIR data, and then if EMR is consuming JSON or Markdown or any format of data, they'll have to write their own adapter. So we have our solution lies here in client side basically. We have we'll start with the demo now. Yes.
Okay, coming to the implementation part, we have built a MedScribe extension. MedScribe extension on top of the Scribe TS SDK open sourced by EgaCare. This SDK can be used by any scribe provider. So by using this SDK, since it is built on top of the standards, you will get the FHIR data out of it. As what we have done, we have built a simple UI over this SDK. That's our Chrome extension. And out of it, we'll get a FHIR data, which we are able to push into any EMR. I'll go with the demo now. I'm seeing Ankit Sharma, 28 years old, who is coming in with mild fever, headache, and sore throat for past 2 days. He has no known history of chronic illness and no known drug allergies. I'm advising a complete blood count test. I prescribe him paracetamol 650 mg, 1 tablet twice daily, tablet cetirizine 10 mg, once daily, vitamin C tablet once daily for 1 week. No procedures are required today. I advise him to drink warm fluids, take adequate rest, avoid cold food. Follow-up is after 5 days or come earlier if the symptoms worsen. After ending the recording, the system could take few seconds while processing that raw transcript into a structured data. Once we get that structured data right now is coming in a standard FHIR format. So we are, right now we have integrated that FHIR data with our Eka EMR, because Eka EMR provides us an adapter. So right now, like as on the extension, we can see it's a FHIR data coming from the prescription we just recorded. Now if I click on push to EMR, it pushed my data into that into this prescription. So what we have done, we have integrated this scribe extension with EkaCare because EkaCare has already written an adapter which consumes that fire data. So now, right now, since it is with only with EkaCare, but later on, if there is any EMR provider which consumes that fire data that is written in that open source standards, so later on we can use this scribe extension with those EMRs to directly fill the data. Or later on, if any scribe provider doesn't want to use this extension, they want their own UI to be built. So we have proposed a solution of TS SDK and Python SDK. So any scribe provider using this SDK can build a minimal layer of UI. From this UI or from that integration, they will get a fire data, which they can directly integrate with any of the EMRs. So that's our solution.
Yeah, can you show me the thing? So the right side panel is the extension that you have created.
Yes.
Which is basically taking FHIR output from the scribe, which is already existing SDK, and then this one is just showcasing it, and then they can map this to their form fields. Is that how it is going to work?
Extension is giving a fire output. Now the left thing is an RX pad. Right now it's an Eka EMR.
I know. What is the extension doing? The FHIR output was coming out of the scribe SDK anyways. What is extension adding to it?
Extension is pushing that data into that EMR.
So it's making an API call.
No, we are like right now we have that Eka EMR access. So what we have done, we have written an adapter. So that adapter consumes the fire data and map the data into their state.
Form fields of the what that EMR is, right? So it's you take this from the fire JSON and you put it into the form fields of that EMR. That's what it is. Can you show me the adapter, please, on the screen?
So here we have the EkaCare has already written this adapter. We are just pushing our data into so basically this adapter.
This adapter is coming from EkaCare, which is like EMR is bringing it.
Yes.
What is your portion? What did this extension do?
This extension is passing that scribe fire data to that EMR.
It's mapping that fire data to these fields.
So basically, extension is doing audio chunking, uploading the audios to Scribe backends, and then pulling the results. So this is giving all functionality in SDK only. So any actually clients, EMR clients, don't need to build this.
They're taking 3 API calls from the SDK and they're chunking it. Can you show me the code for the extension?
Yes.
I'm hoping it's a HTML thing. Yeah, so it's just an HTML.
This whole thing was built.
This white thing is built by this is the extension, right?
Yeah, this extension is built by us.
Okay, I think it's clear.
Yeah, it's a.
Can I just, for the idea, can you go back to that slide? I just want to see the picture you drew, where you had a more generic approach.
Yes.
Yeah. No, because see, essentially, this will be like on your screen, and it doesn't matter what your EMR is.
So approach I understand, but I'm saying this extension, my scribe provider is giving out one.
You're on FHIR format, yeah.
See, if all of them are giving FHIR format, I can directly write.
No, but you still need somebody to do that job, right?
Yeah, you need a It's a screen extension. It's a screen component.
So technically, what you have said is that EMR A adapter A existed, which is in this case from EkaCare.
Correct.
And scribe provider A existed, which is from again EkaCare.
Correct.
And what you have built is that capture, push, and integrate in some sense in this scenario, right?
Yes, I mean from scribe providers, our SDK will call the scribe provider, any scribe providers, not only EkaCare. Just will plug in
Screen that you showed right now, you don't have a choice of scribe providers in some sense, right? So if I go back to your what you have built,
okay,
you don't have like I can't change, like I can change a model. I can't change from Eka to something else at this point, at least not in the demo.
So in configuration, it isn't there.
Okay, it's okay. I think I get it. No, that's okay. I was looking at your scribe, the Met scribe. If you just can go back up to the UI. Yeah, do a back, or start another one, recording. Okay, so it says, okay, it does give you that. All right, thank you. I think I'm clear about what you have built, and now I understand it better. Sorry for the questions. Thanks.
Thanks.
Okay, that concludes our track 2, which is the scribe to integration teams. We will proceed to track 1. Rajesh sir and Suhail sir, we have shared a Google form with you. So you can use that to evaluate the track 1 participants, and we'll get the responses here in just.
Sure.
Thank you, sir. So, with sir, okay, we can give one of our laptops. Jay?
Yes. And we'll just get a laptop so both of them also can.
Sir, I'll take the blank ones and add names of the teams already, so that. Just take the blank. Have the room?
So
Yeah, exactly. Everyone can hear it there. Yeah.
then I asked them to disconnect.
I'll
Sorry, teams, for that delay. We'll proceed with setting up the first team for the first track. Team Tech Devs, are you guys here?
Tech devs are yes. Yes, I have. They're sorting after that.
So basically, this application we have built is for offline, like for ASHA workers where there is no internet coverage or anything. So we have built a custom model that is, there are three main features. That is cough analyzer for diseases and skin analyzer like specific diseases. So we have just taken 20 diseases and trained them to so we have trained 20 diseases which are most common in rural areas. So when they take the image of that, it can give them a specific disease which we have trained. And even the cough analyzer, so for example, if you upload the audio, if a cough or speak on the audio, it will say which type of disease. For that, we have just analyzed 5 type of diseases. And heartbeat analyzer is like RPPG model, where you will just show the face. It will analyze the RGB, that is the face. First, it will lock to the forehead. I'll just play the video. So basically, the person or the user has to lock to the face for 30 seconds without moving, and the light should be reflected. So there is no shortage of light should be there. Like the light should be there. The person shouldn't be like in the less light. So it will be starting for 30 seconds. It will analyze the RGB model. First, it will lock on the forehead. Then it will be like the pixel values to be calculating. Then after that, it will analyze the BPM, SpO2. The BPM is a pulse rate, which it gives. And the AI summary we have given to the Olama, that is the offline model Olama 3.1. So from there, we will get the BPM and the SpO2 and HRV. So there is a slight 5% delay. So we have tested in the BPM machine also. So there is a 5% delay between the mobile and this. So it runs completely offline. We have not used any model for this. Like we are just calculating the pixels values of the face. Like in 30 seconds, first it captures the 10 seconds. It will lock the face. So if any movement happens, it will just completely revert it to again, and it will start again, because the pixel values have gone anywhere. That's why. So it will keep starting again until the pixel values keep matching. Though, so the person has to be still for 30 seconds and be in the same positions. So, for example, if the person breathes, like every like in the skin, when the heartbeat happens, hemoglobin and the green light levels changes, right? So that's how it works. And there's a skin analyzer, which I said I have trained using 20 diseases. So when the person uploads the image of the skin, it will analyze this.
Sorry, your name?
Aryan Gupta.
Aryan.
Aryan Gupta.
Aryan. All of these are proprietary tech now. What you guys have built, or you're using any plugins? What do you?
No, we are just using Olama for AI processing. If you didn't use Olama, it will give like labeling part only 0, 1 like that in the data set. So we are just using Olama to give the output. It's there.
Where is the algorithm for the SpO2 and the
it's in the code files.
No. Where did you get the algorithm for? How do you know this algorithm is correct?
I just researched it.
Yeah?
Yeah.
So it is from some journal or something?
Journal, yeah.
So it's a algorithm which is published somewhere, and then
It's not published. We have like other products have like finger scanning. We just tried it like through face. We have tried it.
Oh, so the same algorithm which is used by after scanning the finger,
so basically
trying to transpose it on the face.
Yeah.
Okay.
Like there are online.
No. This is not like that. There are algorithms which are there in the market. It reads the movement of blood in the arteries in the face.
Yes.
And then this is a 1960 publication in Lancet. So there are like proven models on this.
Yeah.
Have you done any parallel study using an actual SpO2 meter or?
Yes, we have done it. I'll show you. So here we are just running it backend, like to show if it is accurate or not in the BP machine we're doing here.
And have you been able to check on the high BP side? Anything which is above 140?
Like what we have done is like in the normal human being, the BP is always will be in 45 and 120, right? So we have logged in there 45 to 85. It will never go behind 45 or above 120.
No, if you know ASHA worker is using this, and any subject, I'm not calling it as a patient, any subject has a BP which is above 120, will your algorithm will be able to catch that?
Yeah, it will be able to catch that. Like
Have
it
you
will
tested
just
it?
no, we have just tested in all patients, like normal users, me and my friend. That's it. We have not tested with high BP patients. We will not able to get the user for that.
No. Okay.
Yeah.
So it does SpO2, BP, low BP, high BP. What else?
And
Where are you running the Olama? Is it on the laptop or is it on the
laptop?
On the laptop, right? But an ASHA worker won't be carrying a laptop, no?
Basically, it's just like in 2 days' time, we weren't able to.
No, I understand. But do you have a model in mind which can run the phone itself?
The phone.
Which model were you using in Olama?
Olama 3 Lava.
Okay, I'm not aware of that. Fair enough. Thank you.
There are equivalent APKs which are there and having SDK, you can embed it in the mobile equivalent version also.
We have just used Olama for text. That's it. And this is the eye scanner. As I said to you, right, we have trained 20, even for eye, we have trained 20 diseases to analyze. So after analyzing, it will fetch the disease which it has disease. It will pass down to Olama and it will give us the user-friendly, like what to do for home care and the type of infection it has detected.
I think we can say thank you. The time's up, right? Yeah, time's up. Yeah. Thank you so much. Yeah. Very nice effort.
Any questions? Any questions?
I thought we asked you a lot of questions.
Hi. Next team is Mad Synapse.
What team is this? नहीं मैं कॉल पे हूँ मैं 8 बजे के बाद फ्री होऊंगा तो कॉल पे हूँ
Yeah, hi, good evening, everyone. So, my team is MedSynapse. So, my project is like Swasthya Vani. So, Swasthya means health, then Vani means voice. So, we have created a Android application. Basically, it's a AI virtual doctor. So, it's a basically completely offline. So, and completely offline for healthcare. So we are actually changing from primary healthcare to an AI voice. No, not perfectly like a doctor. We are not changing perfectly doctor. We are just making a primary healthcare help with the AI. So here the problem statement is million lakhs timely access to the primary healthcare. So basically, this is unsafe, and they may go in some unsafe medications in sometimes. So even in some rural connectivity, we don't have some internet access. So we have planned a completely offline Android application where it can able to suggest some medications to the doctors, to the patients that can be helpful for some days, and they can able to recover from that. So yeah, as said, the shift from primary healthcare is like we are doctor dependent. So it is like AI assisted first response. So basically, it's a healthcare. It gives some helpful medications to come back from it. Then it is internet independent. Doesn't connect with internet as said. So and the text based completely, you can able to speak with AI comfortably. There is no any internet access or any cloud connected, so that's the advantages. So here we have used lightweight NLP, that is like TensorFlow Lite. So this can able to train the model in such a way that it can able to train the next medications, even though if any patients have faced, and it's a rule-based medical questions flow where the AI asks each question based where the person is facing is any issues in detail. So if the person is in cold, how many days he has a cold, in detailed progress, it goes in step-by-step process. So basically, when we go to the model level, at first it captures voice, then it understands the symptoms, whatever the patient is facing as symptoms, it just understands, and it asks medical questions regarding to the symptoms. Then it gives the risk and triage, whether it is a danger zone or the safe zone. And then we go to the guidance, what exactly the patient to be guided, what are the medications to be taken. So here we have, it runs in low Android devices. Basically, it's just a 20 MB applications. Basically, I have not yet published in some Google Play Store. It's just an APK. So I have developed an APK, and it just needs only low battery storage where you can able to run within 32 GB of storage or 2 GB of RAM. It's a minimum of that. Yeah, sure, yeah. So here, not a data set, actually JSON format. We have completed a complete JSON format. So we have trained a JSON format such as, at first, if he has a cold, so as a cold, he has to take these medications. So as a JSON schema, we have for... basically standard treatment guidelines. Yeah, basically, yeah. What you used to train, what have you trained? Yeah, exactly. Is there a fundamental model underlying, or it's a basic? It's a basic model. ML. Yeah, ML model. So here's a demo, like it's a screen recording. I think I'm good to play. So here network connection, network is everything offline.
Good day, I'm your AI health assistant. May I know your name, please? Geeta. Thank you. How old are you? 60 years old. Got it. And your gender, male, female, or other? Female. I see. Do you have any existing medical conditions like diabetes, hypertension, or asthma? Asthma. Thank you. Now, please tell me what brings you here today. What symptoms are you experiencing? I have cold. I understand you have cold. How long have you had this symptom? 4 days. Okay, how severe is it? mild, moderate, or severe? Mild. Thank you for all the information, Geeta. You can monitor these symptoms with self-care measures. Ensure adequate rest, hydration, and nutrition. If symptoms worsen or persist beyond 3 days, please consult a doctor. Is there anything else you'd like to discuss? Or you can say thank you to end our consultation.
Thank you.
Thank you. Thank you. You're welcome. Feel better soon. If you need help again, I'm here for you. Take care.
Have you heard of small language models?
Yes, sir.
So, do you think that instead of this approach that you've taken with an NLP,
Yeah.
you could have actually built this using existing or reasonably sized small language models?
Actually, we can, but my plan was to build a large model. So I have just started with with the NLP, so that I can able to build larger model in the future. So that was my plan. Because we had 48 hours of time, so we had just started with the TensorFlow model, like a base. It's a light model itself.
And what are you using for NLP?
TensorFlow.
TensorFlow, okay. Yeah.
Any questions online judges?
Anybody, Suhail or others on the online? Rajesh sir? Okay, thank you.
Yeah, I do have.
Go ahead,
Sorry.
sir. Go ahead.
See, I understand that cold and saying that, how severe is the cold. But even if you go to a typical doctor chamber, he will ask you whether the cold is followed by or coupled with sneezing, whether you have a running nose, asking severe, mild, or, those are very subjective questions. I will say something, severe as mild or mild as medium, whatever it is. But the challenge is that, and these cohorts are there and there are millions such use cases, but challenge is how deeper you go into them before coming to a decision that take a rest or, take this medication. Have you done that kind of a deeper, and has it been tested in comparison to a typical doctor prescription in the primary health care center?
Not as a such now, sir. So basically, this is a basic model. So I have this was built to show how the offline AI application will run. This can be developed as such if there is needed. So if this is helping future in my future, so I can able to develop that such application in some meanwhile time. So yeah, I will consider this comment. I'll make sure that I can upgrade the application along with your comments. Thank you.
Thank you.
Thank you. Our next team is Grey Hairs.
Sorry, could we repeat the name?
We are Team Grey Hairs from Zyvalor Labs. Shall we start? Yes, before I start, how many of you have recently processed their OPD claims? Can you raise your hands? OPD claims. I see very few hands. Not that OPD isn't important, but there's no proper system to handle this in a large scale. So we've built Clear Claims, an AI-powered instant OPD claim adjudication infrastructure. Right? So what's the problem and why aren't there any big players in OPD? So if you see, an average claim value of an OPD insurance is around 1,250, and the cost that it incurs for a TPA is almost 150. So it's not economically viable for a TPA to do it. In fact, they lose money even before they start processing it, right? So what we do is we try to bring an infrastructure layer that adjudicates in less than 10 rupees and in less than 2 minutes of your time, right? So that's what we claim to do. So this enables us to tap into 37 billion market that's currently not utilized just because of this economical factor. So what have we built? Let's dive back into the demo. So we have two journeys here. One is for the patient, another for the insurer. So let's start with the patient journey. Let's assume that patient has a phone app that's TPA provided. So I can come, enter my name. I can say I can say the value that I want to claim. Now, I have given two insurers here. I can choose any one. Policies are different based on each corporate, each person. So if you see, there are many sublimits, limits, things to note, things are not covered. So there are a lot of constraints, and this basically is a long document, mostly with images and all those. This complexity just grows. So you can, for now, I've given two options, but you can do it on the fly also. And now I'm going to upload a prescription. It can be anything, but for now I've taken this. So if you see, this is an handwritten prescription written by a doctor. It has various medicines, frequencies and all those. I'm going to upload this. And I'm going to upload an invoice. Again, if you see, this is another invoice. Now, the problem with India is there's no standard invoice template, standard prescription template. There are companies or pharmacies who just give you random memos also. Sometimes there's no seal, sometimes there's no correct format, there's sometimes GSTs, etc., etc., etc. So this is a very common problem across. So let's assume that, let's take this invoice. Now you can also upload any supporting documents. Let's say you went for an OPD and he asked for an X-ray, etc., right? So you can upload all those as evidence. But right now I'm just going without it. So I'm processing it. Now, behind the hood, I'm already adjudicating it. You could see the documents that I uploaded. Now, let's assume this is the journey of a patient. Now, I go back, I log in as a doctor, I go to my insurance portal. Now you would already see my claim that's getting processed. So for time being, I'll go here. This is the same thing I did before this. So if you see, the name I gave was Aravelli and the insurer name was something else. So if you could see a carousel saying patient name doesn't match. It's just not this. Any insight that will help you to adjudicate this faster, better. It may be a name change. It may be a spelling mistake. It may be an edit on top of your invoice. We do fake analysis. We do digitization. We do policy matching. We do a lot more features. So you will get those insight. You see diagnosis. We give you the diagnosis based on the extraction that we had. We give you all the details that we possibly could extract from the images. Now I go next step. I have categorized this into three. Now, if there are any lab tests, those will fall under here, medicines fall under here, and others. Now, what we have done here is, all the medicines that we see here are extracted and grounded. Now, I check if this medicine is available in my prescription. Because most of the times, that's how you verify whether this is part of your medicine or not. So we first see if that's part of your prescription. And if there is, we match it. If not, we say there is no similar medicine. We even go one level deep. We do even salts. So we match even your salts. If there is even no salt match, then we straight up say no. And then we give all those. Now, there are others. What happens is, in your normal bill, you would see GSTs, you would see discounts, you would see syringe. All these are categorized as others. So all these are categorized, and now we bundled it. Next step, if you see, I've given 305. The reason is, this 50 rupees, we have not counted it, right? So that's how you can get the right reimbursement. And one more thing is, let's say I don't obey to this, I want to change. As a doctor, I could come and override this anytime. So this gives the TPA or the doctor immense time saving that they can do, they can become more than 70% efficient using this, right? And then you can come and submit, and you will see your submitted thing. You can see your insurance, all those, right? View summary and all those. So behind the hood, we do a lot of more things like, we do fake analysis. Like, in fake also, we have different categories. I'll just quickly wind up.
Yeah. Okay. I think you can. I think it's good.
Sure.
Sorry, guys. Okay, but we'll ask. What are you using for OCR?
Right. Thanks for asking. So we have orchestrator on top. What we do is we first predict your image. You could have claimed that it has prescription, but we first predict, so we classify. So we use our own classifier.
Classifier is okay. I mean, how do you
Then, based on the classification, then we have a custom document AI model. It's a model that's provided by Gemini. Google, you have to annotate. You have to take different types of prescriptions.
So basically, what you have done is a lot of annotation based on the kind of prescriptions and the invoices India has.
And lab reports also.
And the lab
policies.
reports also.
So we have a good corpus of data.
And how are you doing the matching of the medicines and the lab tests and all of that?
Simple. So once we have the OCR output, we have the medicines extracted from invoice and the output of prescription. Now we do a analysis. Now we have a lookup.
Oh, you're doing it against the prescription,
Yes.
just between them.
Yes, and the next step is against the policy. What if I have
would
fever
want-
and fever is not even in your policy? Then we don't give you.
Yeah, and how are you extracting policy data?
That's what I said. So our document OCR, we have a bucket system, right?
Even policies you are extracting out of the PDFs of the policies.
Yes, we do it.
Like there can be multiple documents defining one
we
policy.
we transform all those into images.
And that's again a Gemini model.
It depends on the model, right? So we don't give everything to Gemini. We pass few to document AI. We pass few to OCR, enterprise OCR, few to Gemini, based on the quality, DPI, the layout, how difficult is
That
it.
choice of models is something that's important. Huh?
It's okay. Yeah. Excellent. Yeah. You're almost a product ready to go out there. Very
Yeah,
well done.
that's one more point. So if any company wants this, this is a SaaS layer or an infrastructure that we built. So tomorrow, if any TPA wants it, they can just plug in with their APIs, their infra, and they're on.
One quick question. You mentioned $10. How did you arrive at that?
Yes, so we've done a lot of testing out of it. We've taken an average OPD claim consists of 5 to 10 documents. Now we claim per image is this much, and then the OpenAI cost, and then the infra cost, which we added, which comes around 6 to 8 rupees, and we've kept a buffer of 2 rupees. So that's averaging that we've done.
And any particular reason you chose OPD versus IPD?
Right. So OPD now in India, the preventive care is improving a lot, and we want to get into the markets as soon as possible. So OPD is the fastest way, which not any existing companies have already entered, and this is our way to get in.
Okay.
Excellent. Yeah. Very good product. Very good demo.
Yeah.
Rajesh sir.
Yeah, fantastic. And you said it. OPD is the future, and the country has to move towards OPD. Claim insurance, because that's the only way to prevent actual enrollment to the hospitals in the IP. I know that you were trying to answer the fake analysis part, because whatever you mentioned about handwritten prescription, non-standardized invoices, matching, fully understood, rule-driven kind of stuff. But tell me, how do you handle fake? Because the major reason why OPD is not managed by TPA is not just 10 rupees versus 250 rupees. Its major reason is the fake part. There are a lot of neighborhood doctors, and not to make a generic statement, but from where the fake prescription originates.
Right. We would classify this fake into categories, right? One is editing on top of a digital document. You morph it, or you whitener it, or you overhike the prices. Or let's say a normal Dolo is 50 rupees, but you claim it as $100. Or there are different forms of fakes that you can cater to. What we do is we have a Google's grounding proofing API model that we have, which is trained on a lot of digital proofs, right? Like digital proofs that we have. So we run it against that. That's check one. Check two is the medicine that we extract. We have a lookup table. So we see if a Dolo is prescribed, is it between the range of acceptance, right? And then we also go one level deeper. How many medicines is he done? Is it matching the policy? So I get a diagnosis of fever, but I'm getting medicines more than that, right? So these are various steps that we try to prevent. It's an evolving market. Zepto has not yet cracked it. Zomato has not yet cracked it. We don't say we've cracked it, but we are saying we're almost there, right? So that's our claim.
Thank you.
Good evening, everyone. Good evening, judges. We are Team Strike Force. Osteoarthritis is one of the most common prevalent joint disorders affecting older adults worldwide. It is characterized by chronic pain, joint stiffness, and a significant reduction in mobility, which greatly impacts a patient's quality of life. Personalized treatment recommendations help minimize risk for patients with comorbidity conditions. Due to aging population and lifestyle factors, the burden of osteoarthritis on healthcare system continues to increase, highlighting the need for early detection and an intelligent clinical support. In 2019, about 538 million people are being affected by osteoarthritis, which is a 113% increase since 1990. Like why others? Like take it me as an example. 20 to 30 years down the lane, even I may be affected by an osteoarthritis. To stop this, without an fitness plan or an early detection or a diet plan, even I can be affected by osteoarthritis. To stop this, this is where our project comes in, an AI-powered clinical decision support system for osteoarthritis care. This is our demo. Medimorph, which means that medical transformation, which we gave our website as a name. And we built out 3 powered features, though one is an deep learning X-ray image analysis, which is an osteoarthritis prediction using the X-ray images. And one more is comorbidity prediction, which means comorbidity means other diseases including osteoarthritis. And the third feature is drug response. Though the 3 features looks different, but they are related. For example, if a person who is suffering from osteoarthritis, the general prescription by a doctor could be a drug called non-steroid anti-inflammatory drug. But if that person also suffers from diabetes, that drug doesn't respond well to the body condition. So to predict this early, we built these 3 features.
Sorry, quick question. This is from a patient perspective or provider perspective, what you guys have built?
Like doctor's perspective, sir. This is the first osteoarthritis prediction using X-ray images, which we built through DenseNet architecture, and we built a validation accuracy. We achieved a validation accuracy of 82%. This is how our AI system predicts the X-ray images, and through this prediction of severity grading, like based on this X-ray image, the R model predicts that this X-ray image person or the patient is being suffered with a grade 3. According to the doctor's reports, the osteoarthritis grades are being generalized like grade 0 to grade 4. Grade 0 is normal and grade 4 is severe. Where the grade 1 is mild, grade 2 is moderate, and grade 3 is severe. Grade 3 is severe, moderate, and grade 4 is severe. And this is the drug response prediction interface, where we took based on lifestyle factors like age, BMI, population type, CRP, OS severity, and disease duration. Why we took as population type? Because there are 2 types of population, Asian and Western. The BMI scale for Asian is different and BMI scale for Western is different. For in Asian, 23 to 25 BMI range is overweight, and above 25 is obese. But according to the Western BMI range, according to the WHO standard, 25 to 29.5 classifies as overweight, and above 29 as obese. So these are something where Western and Asian BMI ranges are different according to the WHO standard. That's the reason why we took a population type as a lifestyle factor. And treatment duration and drug type. So based on these lifestyle factors, our model predicts like how the drug response is good, moderate, or how. One last. And comorbidity is also same. We take the lifestyle factors, and according to our mentor's suggestion, like he told us to build a visualization type, like where the particular comorbidity disease or pain the patient gets, and we use that visualization through 3JS, and that's how. So based on these 36 hours, that's how we built. That's it. And this is just our demos.
Do you guys research if there are other products which are already doing this in today's market?
Like based on our research in 48 hours, like most of the papers or most of the people, they just went through the osteoarthritis prediction using X-rays. So, like I didn't find any like
There are no
existing
current tools that doctors use for this.
Yes, sir. And even yesterday we had a keynote session like from Akrit sir, like where he told us to look out for a manual method where the doctors are going through the manual method, and this problem is a manual method. There is no any system or any AI system for it. So that's where we wanted to build it more accurately.
Where did you get the data set for training?
The OA data set is we took from a public data set called Mendeley data. OA.
Is it Indian? Is it Eastern? Is it Western? Which data set is it?
Like the X-ray images was public, sir, but for comorbidity prediction and
No,
drug
for
response,
X-ray, that public database images are from which region? And does it apply to the Indian regions also? We don't know.
like I don't know. I took a public.
Is it a global thing? If I do it on
Yes,
an
sir,
X
it's a global
database,
thing.
it should be applicable.
It's a global thing, sir. But for drug response and like comorbidity prediction, we didn't get a public data set. So to build it, yeah, based on the WHO parameters, we built a synthetic data set we generated, sir.
Which
Any-
WHO?
Sir?
No. So when you were doing that computer visioning using X-ray imaging,
Yes.
So how do you make a distinction between a fractured knee versus an osteoarthritis knees?
Like how we classify the diseases, like how the grades were.
Diseases.
Like
Yeah.
based on the bone structure and the there's a bone difference between the tibia and the fibula, sir. And based on the data augmentation, we train the model, sir. Like based on different data augmentation, like rotating it or by shifting it sidewise. So different data augmentation layers we went through, and we achieved a like a validation accuracy of 82%.
And when you say 82%, how you been able to figure it out? It's 82%. I'm not saying 81 versus 83, but at a broader level, how was it done? Because generally, how it is done through a blind study. You
Yes,
know,
sir.
go ahead.
So when I said the particular data set which I took was the Mendeley data set, where
Mhm.
1024 images was labeled, and the other 2000
Okay.
images were unlabeled, and which where we took that as our test cases, sir.
Clear.
So like for
Clear.
in this
Clear.
2 days.
Clear.
sir.
Clear.
Thank you, sir.
Very well done in such a short time, yeah? A lot of work, a lot of effort. Good job.
Cool. Thanks, guys. Our next team is CareGrid. They are participating online, so you'll be seeing them on the Zoom call.
Hi guys, are you able to hear me out over here?
Yeah, we can hear you. Just a minute. We're getting your screen now.
Yeah, I'll just share my screen. Are you guys able to share my see my screen over here?
Yeah, just give it a.
Just 1 second.
Okay.
Could we also request everyone to, follow the timelines because we have a hard stop at 9 o'clock here for this space.
Sure. Can we start now?
Yes.
Okay, guys, this is Team CareGrid. NH employees with a little bit of clinical and non-clinical insights. So we are not trying to build a traditional CRM like Salesforce, where you spend tens of crores in implementation in a partnership agency to get it implemented just to dump down leads. And we have around at NH 260 call center agents taking 240,000 calls. And most of the hospital systems are sitting at 60% bed occupancy rate. Pharmacy fulfillment rate and lab and radiology fulfillment rate is another problem. And OP to IP ratio is roughly around 10% for all the listed companies. So we are trying to build an agentic system that reduces your leakages, increases your revenue, and basically increases the health outcomes over a period of time. How we do it, I'll just go down to the slides quickly. So most of the OPD events are very isolated, be it through chaos, be it through call, be it through in-person appointments, or be it directly in IPD. The communication channels are completely fragmented today, and none of them talk to each other very well. And same with the clinical pathways as well. So what you have is missed outcomes, you have lost revenue, and all the other metrics that we have discussed, the most important one being leakage. So we have built a 360-degree patient view, which not only gives you the clinical opportunities, but it also gives you the non-clinical revenue opportunities that you have with the patient over a period of time across all the verticals. And it communicates with the patients on a real-time basis versus requiring a manual human to do it. You can also have a human in the loop, as you can see it. Fire native, well, I think a lot of startups have talked about it, but it's more of a compliance thing than anything else. And again, a view of it. I think we'll go through a demo very quickly. For voice calls, we are using the infra layer that we built in last hackathon. And this is a voice infra layer that we are able to collect history and all of that. Same with the WhatsApp communication and web AI widget itself. And we are structuring the data. 80% of clinical data is unstructured. Forget about applying AI on top of it. We are structuring the data over here as well. Same thing, you can either use our voice bots off the shelf. You can write your own JSON scripts and get started with the voice bots, or you can have human in the loop, for severe cases out over there, especially the IPD cases and all. And we have executable care journeys. You can set up your own care journeys. You're using our agentic system out over here. We have built a system which is on parallel to Entertain, and you can create your own agents and manage your own journeys as and how your operations requires it. Same thing with support, same thing with escalation, and we get the leakage visibility. That's the most important thing today for most of the hospital systems and the clinics. If your inbound is sorted, but if you're not converting them, you're losing money on the table today, and that is very important. And
So, just I think I'll take over in terms of the
sure,
demo that is there.
yes.
I think you're at halfway mark. So yeah, just quickly.
Yeah.
Can you see my screen?
Yeah.
Yeah. So our initial hypothesis that was there. And by the way, hi Rajiv sir, hi Sohail, hi Vikas and Jay, good to be back. So our initial hypothesis, we started with the voicebot thing to facilitate the patient side of things in terms of voicebot that would come in terms of an OPD appointment and telephony. This is the first thing we built out. However, eventually we realized that we need to take care of the entire hospital personnel, what they're doing, and streamline their entire flows. So if you see, we basically created like an AI assistant sitting in front for the hospital personnel with an intent classifier with a bunch of tools and MCPs that connects to the CRM where data goes in, and the bunch of EHR EMRs that are also integrated. So this is like a high-level system diagram. This is the voice bot that we started with. We created an entire product out of it called Zoids.ai. We are integrating this as our backend voice-based providers. And this is the essentially what we have built out currently. So as you can see, a typical flow requires a lot of form filling for the hospital personnel and anyone coming in. That kind of like destroys the experience for them. Also, they also need to spend a lot of time doing this. Instead, what we have done is basically have a clinical assistant where it kind of parses all your queries, figures out is connected to the entire database CRM backend, and then based on that, it fetches all the data. For example, if I see get me details for patient 9844.73. So it's able to process that query, go into the database and fetch all the specific details. Get me medications for this. It's able to fetch the specific medical records. So for the medical records part, we had an overambitious setup and we tried to get in and integrate a bunch of Eka Care APIs, etc. But it proved to be too much for the hackathon. So we have just basically listed it down and put it currently just sort of as a demo. And additionally, it can also help manage like for Dr. Sarah, tell me the slots. So it's able to fetch out all the slots and book an appointment.
Guys, last 1.5 minutes.
Yeah. It's Dr. Sarah. So therein it's able to like basically find the details. If you see the conversation history that I've had, like if I just select appointment, it finds all the departments, the specific doctors that are there. Book 10 a.m. appointment for Dr. Sarah Michelle for this patient, then it books it. And then also we have connected, we are planning to connect with the Twilio MCP, etc., where it can actively go and fetch, send the confirmation SMS, etc. So this currently, like if we send successfully to that particular patient, this entire setup is to facilitate the healthcare personnel or streamline all the different flows within the hospital per se. And then that is also powered by the EHR EMR layer where all the clinical and non-clinical data is sitting. So we have started with patient practitioner organizations. And this is like a one-stop shop, 360-degree view where given to all the hospital-related practitioners as well as personnel. Our hypothesis was slightly different. We did not want to get deep into the clinical flow. Everyone is solving for that. We realized the hospital personnel are generally in a very grumpy mood because everyone is like it's a very high stress, high anxiety environment, and everyone is just like sort of antagonistic to each other. So if we take care of them, subsequent side effect would be that the patient experience would also be increasing. And yeah, so this is what we are attempting. We have been discussing this with a bunch of hospitals, and then we formulated this basically problem statement.
Yeah, that's it. Thanks, guys.
Hey, thanks, guys. Quick question. Did you guys build this over the last couple of days or it's an active project?
So the voice part is an active project. What we built out is this dashboard, and like thanks to Cloud Code, we have been able to move very fast. We defined the workflows. I work very extensively with Cloud Code. I have a lot of experience in like data, healthcare, and clinical and non-clinical workflows. So I just defined all the different backend APIs. It was able to spit out the code in like the whole of last night. It just spent on coding.
Got it. And you, I heard somewhere you mentioned NH. What was that? You guys work in NH?
Yeah, so we employees of NH. I have moved on from NH. I have my own company, Kuzushi Lab. We do hard, deep generative AI problems for a bunch of enterprise startups. So yeah, we are very AI native in everything we do.
Okay, great. Just wanted to highlight that this I don't know if you think this is a very big market to solve for. How many hospitals actually will look to implement solutions of this nature, right? Very few guys actually run this problem of revenue leakage. Most don't even know or appreciate the problem.
So what we can do
is one of those. Yeah, Sajid, over to you.
Yeah. So the thing is, we not only talk about revenue leakage over here, we can also get you revenue over a period of time. Not every small setup can run a call center operation of its own. Not everyone is Cloud9, not everyone is NH, or not everyone is Medanta today. So the smaller players, what we can do is we can, reduce their capex and opex. We can give them a call center which is AI enabled. We can give them more leads over a period of time that they can work on and build up their patient base over a period of time. So small hospitals can use it as a lead generation agent, but we will be compliant with the DPDP Act and will not be passing on patient data from one hospital to the other. That's something we'll be very clear about, but we can, sort of offer it as a service to them versus them setting up their own service like the bigger chains out over there. So it's applicable to all because everyone wants revenue. So if you don't have revenue, you have to shut down your hospital. So that's
and this also enables like a continuous touch point in terms of like voice follow voice calls, follow chatbots, etc. And we have had good like demand coming in from smaller clinics
guys, the time's
that are setting up.
Yeah,
got it.
Yeah, okay. I just want to add one thing. So last hackathon, like if any AWS guys are there, we won the third prize. We are still awaiting our 5,000 credits from AWS. So just a shout out on that. Any AWS guys, please reach out. Like if you are giving credits and prize, ideally it should be unconditional. We tried like a lot of hoops we were made to jump through, still nothing. So yeah,
he'll give you more. He'll give you more. Thanks for pointing it out. He'll give you more.
Thank you. They will give you with the interest. Don't worry. But tell me, you are building this CRM. So for how does this integrate with the core EMR One for OPD, post doctor consult, and second for IPD, post discharge. Because it's not just the revenue, it's also continuity of care.
Yes, sir. So currently what we are doing is Atma and Eka Care has API. So we are targeting people who have already in the Eka Care system. We are chatting with them. And we are targeting greenfield hospitals that are still undecided because we realize this is like a 50,000 rupees my lifetime for this entire product sort of a thing. So it's not a very money making thing, but we want to facilitate that and we want to basically not charge doctor or patient, but eventually like expand their entire
I
pie.
got it. So
And then,
currently it is catering to ECA on the OPD side.
yes, yes.
Sir,
And
in post
there are a lot of
IPD,
greenfield
Luna,
operations that are coming in.
can I take this? So, sir, see, post IPD, you need to give continuum of care out over there. You need a care plan. Most of the hospitals, even if they have a care plan, it's on pen and paper today. So we can enable hospitals like yours and other hospitals out over there to create a continuous care plan using our agents out over there, and you
How does
use
this
any of the
agent speak to? No, I fully understand. This concept. I just want to understand that how technically these agents are going to speak to legacy HIS and EMR.
Cool. I think that's it, guys.
So-
You don't have to. I think we have to stop.
That's an integration challenge, sir, that we are slowly going through. It will take about a year.
Perfect.
Yeah, I think that's it from me. Yeah. Next team is Console Terror. You can start.
Okay, good evening, everyone. So, first of all, we have seen a lot of good solutions. Many you are also trying to solve the diagnostic part of the application in health and AI innovation. But the main problem, which usually every single person who hops into this domain is the availability of data. What's happening? Like, let's say, I'll give a quick example. Today, I am interested to solve a particular problem which is about some extra images. I'll go to some online public resources. Usually I'll get some public data sets, but are they currently updated up to the current trends? Like there can be any single thing, any changes in health on every single day, right? So the data is not dynamic. Then comes the complete consent that is being managed by every single healthcare providers who usually manage all of the EMRs. We have known like a lot of players are also doing the management of EMR. But there is a slight gap between these researchers and the EMR managers. That is where these EMR managers can literally help the complete health innovation domain by providing the data, like the meaningful data for these researchers. But yeah, how can they just give something which is very proprietary for them? How would they just sell? So that is what we are trying to solve. So we have our own defined consent terms and policies, which will be explained by Nalin. Yeah.
So these consents are given by the patients, and so how does the patient sign these consents? Like, okay, like these are my ECG, X-ray certificates, and you can use these for maximum 2 years, and that's all. Suppose what happens is, so what our portal does is, a patient onboards into the portal, and then he and doctor basically, if patient allows for a consent, he can just upload it. And how our workflow, how our engine works is, we use the consent. We first of all we use OCR to extract all the major contents from the consent about like what are the diseases, what are the symptoms, what are we talking about, and then we use that and feed it to LLM. And after feeding it to LLM, we generate something known as policies. Now, why do we generate these policies? These policies are important for the researchers to basically know that if they are allowed to use those type of data for their own research or not. So how do we do this? Basically, in an LLM, while we are giving the prompt, we assign a confidence score to an LLM. We tell it that it has to give a confidence score to LLM. If the consent or if the policy that is designed is not below below a particular threshold, then it is sent back for the human review, and it won't be stored in the database, so for the researchers to use it. So yeah, that's where we close the gap for our consent uploading. And to maintain all these, and since as he told that data keeps on upgrading, someone's health might get affected later point of time, due to which data sets are not really reliable. So we maintain versions also for these consents, because one consent can't be same there for everything, right? So if we maintain versions for these consents, then it's really good and it will be updated, and so researchers will always have an actual data to work for.
Can you show us something? Can you show us?
Also, guys, how does this change given what DPDP is supposed to do?
Sir, DPDP basically, like, suppose if he has mentioned his name, right? Suppose the patient has mentioned his name. So under the DPDP compliance, we ensure that, suppose if researcher gets his name, obviously researcher, we ensure that he won't get his name. And when transferring these things, we use the FHI compilance. We use compile with the FHI policy. So all of this data is transferred in their format only. But for us to evaluate it and for us to actually use it, we just transfer it in terms of something known as policies, because FHI data, using it in the backend and in the database, it takes a lot of query optimization, and it's like really, it takes a lot of runtime.
And
so
so
you
the
got-
assumption is also that the researchers will use this product, is it?
Yeah, basically all those, not just researchers, any single startup or anyone who wants to delve into
data,
healthcare innovation.
right.
Okay, so you can see the demo here, and I want to just make a small note. Recently, we faced AWS outage. Likewise, we were using Superbase as our database provider, and that is also facing a maintenance issue, so we cannot show the live demo here. But yeah, so once you could also see the complete flow, right? So the basic and major idea is to make data accessible for every single person who's there and who wants to build something. So this is what we try to build in this complete thing. And also you could see a lot of elements here, like summary, stats, unique values. So let's say the researcher is not just a machine learning engineer or who knows something about AI. So we also try to give a lot of tools which will be helpful for them for exploratory data analysis and many other features, so that they can analyze the patterns and the current trends. And the main and unique feature is, which I also mentioned in the start, that the complete thing will be dynamic. It will be getting updated for every single day's data. So yeah, because every single healthcare and EMR providers, all of them will be updating their databases, and you could see in the flow also, once the database updated, the consent is also enforced, and if it's policy applicable, then they are also updated. Thank you.
Thank you.
Our next team is CarePal. Over to you.
Sorry, I missed the previous team's name. If you could repeat that.
Console Terror.
Thank you.
Suhail, after this, there are 3 more.
So this is our team is CarePal. Myself is Isa. This is Amina. So CarePal is basically a solution which has a device that's an assistant or a companion that sits at the bedside of a patient that is at home. So we're trying to bridge the home health, hospital home care continuum. So what this device can do is it can talk to the patient, it can see the patient, as well as it acts as a hub that can collect values from different devices. So for example, different vitals as in home care devices, that is BP, glucose, SpO2 and everything. So we have a demo example here, which is a BP monitor.
So I'll take the value that will be directly connected, that value gets captured in the CarePal. So meanwhile, Isa will continue the presentation.
So it takes, I think, 2 minutes to finish the recording, so I'll go ahead with the rest. So what we have is, we have a hardware device that is sitting inside which collects data from Bluetooth devices as well as over the internet or Wi-Fi. And we also support the ventilators and patient monitors as well. So we have a small adapter that can translate whatever a ventilator or a patient monitor can say and then onto a interoperable platform. So what we are trying to focus here is a vendor agnostic solution which does not depend on one specific manufacturer, and anyone with an existing device, they can use our platform or they can add our assistant and then use them. So that gets automatically reflected over here without any patient input. And the actual use case is purely we have an AI that is sitting inside here with vision capability, and then you can talk to it. I don't think in the mic scenario it might. Hello? So basically how it works is yeah.
Hello, can you hear me? I see you're presenting, Harun. I'll just adjust the view to keep you centered. Is everything going well?
Yeah, everything is going well. So what it can do is it can rotate the head as well as it can see the patient, it can pan around. So for example, if a patient has a fall or if it's a bedridden patient and the patient is not being seen on the bed, the AI can decide itself to turn around and look around for the patient and get insights or escalate on top of it. So our main priority here is these are geriatric patients. There should be zero tech barrier. We can't give them an app and then ask them to use the app regularly or check up on their, or even if it is a voice-to-voice interaction on an app, I think it's also participating here. Even if it's an app on a phone, the people won't actually use it. If it's a device like this sitting at the bedside, geriatric patients may have. So proactive engagement is what we're trying to do. Instead of user asking the AI about questions, the device will itself get active on medication reminders. So if it will ask you, did you take your pill on the morning? And from the response, we can also see if the patient is adhering to the medication. Yeah. And the monitoring part is what we have demonstrated now. And this is something that we have in the pipeline. So it is a two-way bridge. Basically, we'll have a phone conversation. So anything emergency happens, we have a separate solution that we have previously developed that has phone capability. So basically, if we integrate it with that, if there's an emergency, it can call the patient, call the doctor. If the doctor did not respond, it can retry as well as follow up and everything. As well as we can give the care pod a phone number, which doctors and their children can use, and then they can call and check up on the patient. And if it's a doctor, it can assign a task. For example, it can call to this care pod and then say, check up on the patient's wound at 9 a.m. tomorrow. And care pod will proactively get active at 9 a.m. and then ask the patient, are you okay? Can you show me the wound? And then it will take a photograph and then, yeah. And then from an ABA perspective, we have integrated ABHA. You can log in using Ayushman Bharat account. as well as this acts as a PHR device. It's like a hardware version of a PHR app.
Guys, how have you built the triaging? What happens in, because it's great in a good to have scenario, right? But if something happens, what's the triaging?
So basically, we were trying to utilize the MedAssist API that ECA has to gather information from our end, provide it to MedAssist, get the priority on how we have to, if we have to make a call on triaging or not, from a trusted medical external source, and then use that to basically the calling feature that I mentioned. So it's an external software that we have developed before. I didn't know we could implement external ones in the hackathon. That's why we did not do it. So basically what it can do is if you tell it a task, it will call the doctor and say whatever, or collect information from the doctor. And if the doctor is busy, if he picks up the call and say, I'm busy, based on the criticality, it can say it's a critical thing you have to interpret, or it can call after 5 minutes, or it can retry. That kind of a solution we do have existing. So that is how we are trying to integrate. And this device is actually our final form, which is basically a smaller device, which does not need to show all the grid and everything. And what we are trying to do is it will be slimmer. The patient can remove it, keep it in their pocket, and then go to places. It's like a companion that they can interact with always. Health goes with them is what we have.
Quick clarification, what part specifically was built in the hackathon and what was already
the
existing?
software and the data from, so what we did, we just 3D printed everything and brought it here. We didn't know. And the rest of everything, including the hardware, we did it from here.
Okay. Did 3D print, just out of curiosity?
At home, I have my.
Cool. Thank you, guys. Our next team is System Hang.
Have a PPT or a PDF file, whatever.
It will be in the present. You just connected the HDMI, right? Yeah.
When you think of maternal health, it's usually the physical checkups, scans, and that's it. No one really thinks about the emotional well-being of the mother. The word going to a psychiatric itself is seen as a negative impact, and a mother saying it is nothing less than a sin in the Indian households. So we built Mahu. The name is supposed to be Ma and You, where we are going to highlight the different hues, the colors of mother. We want to help them out emotionally through an AI agent, and not because they would not be so comfortable going and speaking to someone as such right now. So we first have the login page that she's doing. We have the emergency contact we'll be taking, because this is taken so that if we find any red flags in the mother, then we should be able to contact the emergency contact that they have given if we feel that they're too depressed about it. And next we have the questions that were asked, and we have put icons and pictures in that so that it is easier for rural people to also understand this. This is the workflow that we have taught to different modules. So the first we have is the mood calendar. So this mood calendar is where I'll be able to put my mood in it. This is an engagement thing so that it's people feel good when they see colors, and each mood is being given a different color, and they can also put a note. This is like a safe space, a diary, a digital diary for them, because henceforth obviously we are more used to typing than writing anything. So that's a digital diary that they can keep, that is secure, that's just for them. Next is the grandma wisdom. So this we have kept so that we can integrate the traditional roots with the modern technology too. There are many such techniques that people don't know about. It's not that, I mean, grandmas tell them, but they don't know why are they doing it. So here we have given such techniques and the scientific reason for it. And these techniques are usually region-based. Based on the climate of that place, the techniques also change. For example, in India, we say that you're not supposed to eat chicken much because it's heat during the maternity. But in Japan, they give egg and chicken together because they say it gives the mother and child vibe for the mother. So we have you'll be able to select filter options. Next is screening. So for screening, we are using EPDS and PHQ-9 questions. These are for the postpartum depression evaluation scale. And so the questions will be given, and they'll be able to, we'll be getting a score out of this, which will give us a risk analysis for them. So based on that risk, we will know how are we supposed to push notifications for them, and if we have to, if the red flags are identified, then will we have to contact the emergency contact or not. That is the screening part. Next, we have the AI chatbot. So this is basically framework that we have taken, agent from Eka that we've used for the this. So the tone is going to be nurturing and human-like, so that if I want to use a chatbot, I can just go for ChatGPT. Why would I ask here? So for that, it's the tone that we have changed here, where I should feel like I'm speaking to a friend and not just someone putting facts on me that do this, do that. I know what's good, what's not. That is not what I'm here for. I'm here for a friend, and that is what Shiro is supposed to give me. So next, after all this, so another part where we want to use AI is in the mood calendar, where they're putting their whole moods. We should get a wrapped, how you get a Spotify wrap, which tells how what have I been listening to, and it helps me reflect on what I've been doing in the whole year. I feel good about it. So we would like to give a MAR app where we give an analysis on how their week has been. Has it been good? Have they been happy more or disappointed more? What they can do according to that. These are the kind of suggestions that we would like to give. That there is a MAR app section. So this was the, we would like to help with the depression part, helping with the postpartum depression, which is rarely spoken at all. So we want to help in that, but not in a way where everyone knows it out loud, because people do not want to talk out loud. That is why we want to help them digitally. So this is between us and the mother. So future enhancements that we want to put is in the medical records. We should be able to give them reminders about the checkups with our calendar, and be able to store their medical records. Right now, we have not put that because there are apps that is doing all that. It's not like it's not there. So there are apps that helps in maintaining the records of a pregnant woman, and there are apps which help in well-being of normal people. But there is nothing that is specifically helping mothers for their emotional wellness. So that is the specific thing that we would like to help. So in future enhancements, obviously we would like to include all the other features that are also available, so that everything is integrated at one place for them. That's the solution. Thank you. Any questions?
Did you build the whole thing in the hackathon?
Yeah, the whole thing was done here.
Oh, nice. Okay.
So do you guys have any background in this space? Why did you pick this mother's emotional wellness as the idea in the area? What is the background to that?
So we have interacted with few mothers. One such case was interacting with our professor, one of our professor. She told us that postpartum depression is the most neglected phase, like most neglected part when it comes to maternity. And also we participated in one more hackathon. IEEE.
Hyderabad, Returning Mothers Conference.
It was based on returning, mothers. The title was Returning Mothers Conference. So in that we had worked on mothers actually.
Well, I just wanted to acknowledge a great set of use cases that you picked up and the right set of problem. Really appreciate the effort that has gone in. And second, I want to apologize to everyone else coming next. I have a non-negotiable meeting starting now. I was hoping I can go through everything, but apologies, I have to skip that. And thank you, Eka team, for making me join this. Really appreciate it.
Thank you, sir.
Thanks, Sohail. Thank you so much. Very, very, very well done. Yeah, lovely
Thank you,
effort.
sir. Thank you.
So, hello everyone. So, we basically work in senior care where continuous monitoring of a device is very beneficial for the safety of a senior. So, as a deployment phase, we have seen that there are like so many raw alerts, which we call as a fall alert. That fall alert can be occur because of quick sitting on a sofa, bending down, or look like a mopping on the floor. So we are a part of a Kubo Care. We basically we have deployed device in the market right now. But why we are here in the hackathon? So hackathon give us a chance to like think back, step back and think like how we can make our product interoperable so that we can integrate our data with different platforms. So what we are in the hackathon, what we try to make is like we have data with us right now of a real resident. We try to create a 3D skeleton visual representation of a person, how it look like, which will also give you the activity insights of that person. That the person is standing, bending, sleeping, or moving around. So we can basically have this activity insights using our device. So I will show you a video. Like this is a current radar. This is a radar device. We are basically a radar AI powered radar device. So this basically the graph look like this when the data basically this is the visual representation of the data, which is not clear. It's not like a video that you can assume that the person is where in the room, and it's not identical. So we basically try to so this is the real platform right now, which will basically show you the person moving in the room, and there's a fall detection. But we will show you what we have done beyond that in this platform. So I can take.
So just to give a brief about what KuboCare is, KuboCare gives you radar devices which replaces cameras from all the old age healthcare facilities. Might do it in hospitals also, because we are deploying our devices in hospitals in Japan. So if you're moving, first thing, we have removed the cameras, we have put the radar device, the identity and the privacy is not an issue anymore. All we see is something moving. And when you fall, we have built our machine learning algorithms that predict whether the given movement of a point cloud was a fall or not. What you just saw here is how we see the point cloud as. So this will not make a lot of sense to a lot of people because they have not worked with this data. This is nothing but XYZ moving in the given time frame. And just a second. Okay. So the first thing that we did was we built a machine learning model, a 3D convolutional model, which predicts whether a fall have occurred or not on the basis of the given radar data. how it flows, what is the velocity, what is the change in the centroid of a user, and everything. But with this, a very small problem came up, which is not a very small problem. So let's say you own a old age healthcare facility, you have 100 rooms. In every room, I say one day, I'll give you one false fall alert, which means on a daily basis, you're going to get 100 false fall alerts, because of which the facility will be continuously on the toes, rushing from one room to another just because of false alerts are coming up. But it's only one fall alert a day. So that's what we planned to solve for in this hackathon. We have built a tool which we can give to our call center folks. They can use this tool to figure out when the fall occurred. They'll pull out the 3D radar data from that given moment. They'll pull that data out and then they'll watch the skeleton move. And they will tell whether the movement of skeleton can be a fall or cannot be a fall. So this is going to act as a verification layer over the prediction that we are already giving as KuboCare. Another thing that this can do is this machine learning model, which generates these postures, these skeletons, can also give us posture recognition. So we can know whether you're sitting on a bench for 6 hours a day, you're laying on your bed for 8 hours a day, or you're just moving around a lot. With this, we can also give you your stride length, your movement. Should I continue? Okay. Yeah, okay. So with this, you can get a lot more insights. And so this is the application which we have. We have built a machine learning model in past 2 days itself to predict the skeleton, not to predict the fall. And we have some raw data flowing in through the CSV. We can So we can predict it and then get the video that you saw in the previous one. So it is just raw data, raw CSV data flowing in. With this, going forward, we plan to give a lot more things: posture recognition, movement tracking to depth. Right now, we only track the movements whether someone is on bed, on the door, or how much time they're taking to go from bed to the door. This has a very long-term benefit. So if I start to monitor your activity on a very daily basis, that how much time you take to go from your door, your bed, to the exit door, and you go there daily on, let's say, morning 9 o'clock, you move out of your bed. Initially, if it takes you 10 minutes or 10 seconds, and with time, if this value is deteriorating, it's becoming 15 seconds, 16 seconds, it means that something is happening to you. Maybe you're injured, maybe you have some pain in your body, pain in your joints, or maybe it could also signify that you might have dementia. So this tracking using point clouds can help one understand anyone's activity in very, very depth. So this is what we at KuboCare do, and this is what we have done in past 2 days.
Check, the model already predicts based on this data, but the skeletal model that you have built, that is for human verification on top of your current model as an edge case.
Yes, human verification, and we'll take this forward as a posture recognition, because we can't recognize posture right now. We can only recognize falls and movement, track movement activities.
Okay, got it. Thank you.
So right now, whenever there's a fall, there's a call center also to reduce the fall. So when there's a fall, we predict a fall score. If the fall score is more than 90%, we directly send it from the back end. But if it's a mid-range, we can't tell that it's proper fall. Then it's go to a call center. He can visualize this data and tell you the proper result.
Radar versus camera. So is there a real strong, like, can most of this be done with video too, right? So
most of this can be done with video too.
So apart from the privacy aspect, is there any other benefit?
If you try to process a video, it is very computationally expensive. But if you are just processing 60 points per second, that's not very computationally expensive. So taking radar data and doing analytics on it, figuring out where the point cloud is very easy. It's mathematics. It's somewhat similar. It's very similar. So at times it's also cheaper than setting up your whole cameras and all.
The main thing in this scenario is like the more of the fall happen in the bathroom where senior people go. So we can't place camera inside this, and that is the main thing we are going to target with this.
Sir, online judges, Raji sir, do you have any questions for them?
No. I think good use case. But one important stuff is that it's not about bathroom. You can't even put a camera even in a normal room. So challenge is that how fast you can send a response to the nursing unit, because not the call center. The nursing unit is the one who is next to the patient bed. So is there any mechanism by which this notification of a false or a potential fall?
Sir, the notification of false has a latency of less than 1 second. We can trigger a fall in less than 1 second. Adding a layer of verification through a call center takes at least 10 seconds more. So within next 15 seconds of a fall, we can trigger it. And in case of a fall and the model says it is 90% that it is actually a fall, the fall's prediction value is very high, we'll directly raise it, which means lesser than 2 seconds, and the calls are going to the caretakers, to the family members, or to whomsoever
Got it.
added in the system. Yeah.
Got it.
Thanks, sir. Thank you.
Cool. Last but not the least, guys, we have Team Flexi Roasters. You have 5 minutes.
Hi everyone, we are Team Flexi Roasters, and we have built an AI model, TriSense AI, in keeping in mind ethics, scalability, and clinical credentials. Yeah, let's go for a demo.
What do you guys do? Sorry. No. What do you guys do?
Yeah,
we can't.
My problem is early clinical deterioration and sepsis detection.
Okay.
Life-threatening condition. Sepsis means life-threatening condition.
Here we are using two ML models like patch TST means patch time series transformers, and the XG boost algorithm. Patch TST algorithm uses to capture the long-term dependency of the vital signals from the ECG something, and the XG boost capture the high risk sharpness of the risk in that. Using these two models, we can collect the signals and predict the risk of the patients, and these risk signals are sent to the nurses who are monitoring these softwares, so it can reduce the workloads of the nurses. Multiple.
This you're saying use in hospital context?
No, in hospital context. It can reduce the workload of the multiple nurses. I will show in the demo. It's not connecting. Mainly, I built the
device also, or
no, not. We are only the models predicts. We are building the prototype for now.
Where are you getting the data from?
We are getting the data from like public data sets. We search
You're detecting in the hospital basis a patient, right?
Yes.
Where are you getting that patient information from?
Our plan is to get from the ECG signals. It's like
from the monitors.
From the monitors. It gives the signals, right? Waves like heartbeat.
Sure.
Like that.
Okay.
The ML model is trained.
Sorry, go ahead. So when you talk about ventilator, which has ECG signal, there are 6 parameters. And there are many other parameters which are there for sepsis detection. Okay, I just want to ask you, what are the 3, 4, 5, 6 parameters which you have considered for sepsis detection?
Heart rate, blood pressure, saturation of the oxygen level in the blood, and blood pressure, something like that, and the temperature of the patients. For which having these parameters, we train the ML model.
Any labs, any radiology,
No.
any cardiac values, any echo, any LVF functions?
No, no. I think I will show the one time the data. Video you can understand, I think. ಹಂಗೆ ಕಮ್ಮಿ ಅವ್ರಿಗೆ.
And how you have built this, where you got the algorithm for finding out is possible sepsis using 5-6 parameters, the one which you mentioned?
Our team is researched on the to use which model to predict the ML. Many of these sepsis data are built on the LSTM and RNN, which captures smalls. So we want to explore which can give more accuracy. More than transformers can capture the long-term difference. So we use as the transformers, which gives the pair. I can stand there.
I think that one.
Rajiv, their laptop is not connecting, so they're just doing the demo for us here.
Sure, no worries.
They're not able to get it to you, unfortunately.
No worries.
It's a prototype, not a full version.
Just to share with you, if we are able to solve this problem, and if a 7-hour early detection of a sepsis, we will reduce the mortality rate by almost 90%. If
It's only for the 3 patients now, for just for prototype.
Explain to us.
I will stand there. The ML model predicts the risk state, and the risk state is passed to the alert agent.
Question that Rajiv asked, we also have this. Why did you choose a separate ML model? I mean, are you trying to work with lesser parameters and still detect sepsis, or are you trying to say I want to increase accuracy? In which case, Rajiv's question was, you need to have much more data rather than just these 4 parameters that you choose.
Yeah, sir, we tried to get the live patient data, sir, but we can't.
I know. Are you sure that just by using these 4 fields, you are able
Yeah.
to get good accuracy?
It's not for it's
Oh, 1 minute.
Heart rate, blood pressure,
SpO2, temperature.
These are the data
5
sets.
fields. When you
File.
He's saying that for a real sepsis detection, when you do LSTN and all, you need more echo or the imaging data also. How are you sure that without imaging data, you're
a lot of lab data also.
lab data also?
Pressure pump, infusion pump, ventilator, radiology, if you have water in your chest.
Enough to detect sepsis at a good rate. By the way, if you could do with 5 parameters, do you have a good algorithm?
That will change everything.
Yeah, it will change everything.
Sepsis predict, it's based on that for heart rate, blood pressure. Not. It's more important than other features. I'm saying like that.
You are saying or science is saying?
For up to my research, I said.
I think we'll have to lower your research, but yeah, great attempt.
Okay.
Thank you.
Thank you.
Thanks for your feedback. Sorry.
Thank you.
Yeah.
All the points we'll just collate it. We'll just collate the points. So these are just 2 external.
So can we do it? So all the numbers that you have marked, right?
We'll just collate the points.
We'll do it together. So right now, just 2 minutes each.
Okay.
There are 2 internal teams.
Cool. So for
some innovation. No. You don't have to evaluate, but you have to just tell us which one of them you like the most. So there is a
separate internal sort of reward for them if they go live. So go for it, guys.
Hello. So our idea is to build Scribe. It's already tried and tested. We are just making some improvements there, where the idea is to run Scribe completely local, on device, no internet connection required. So no data leaves your phone. So we are pitching it for people in low internet areas, like in rural areas, and for patients who don't want to share their data. So the thing is, though Scribe data mostly is stored safe, we cannot assure that all companies, except EkaCare, store their data safe. So, and about going live, this is the live app that we have on for EkaScribe. It's already integrated. Probably by next week, we'll have test flight build and we'll go live. So I just turn on the privacy mode, and I can start. Patient has fever, take paracetamol tablet morning and in the evening for 5 days. You have a follow-up after 10 days. You might have throat pain, so we'll check it after you return. Yeah, so I guess it just skipped. Anyway. So we have apps for both iPhone, iPads, and Macs, and it's almost production ready. And it's the model is trained on all local languages of India. So Hindi, Tamil, Telugu, all the languages will work. And the end-to-end, it's completely offline. It creates the clinical notes, transcript, and it generates the PDF. If you want to print it or share it with anyone else, you can do it. What is the exact report? So we have two models. One is Whisper. We trained with 26,000 hours of Indian languages. And we got the data from where?
Yeah, like we use data sets from ArtPark, A for Bharat, like they provide, like they have good open source data sets for Indian language. Yeah. So there were two models. One was Whisper, which was fine-tuned to work on Indian languages, and there is one more as Gamma, which is 1 billion parameter model. That is also fine-tuned on Indian clinical notes data set. Yeah.
So they don't have a small language model or anything to actually structure the data?
We showed the structured data.
So what are you using for that?
That's Gamma. That's Gamma.
So Whisper's data will be all, we process that and, yeah.
Very nice. Actually, very valuable use case for in public health setups.
Yeah.
Hey, will Whisper work on an Android normal?
Yeah, it just consumes 5 GB or 4 GB of RAM.
4 GB. Gemma?
Yep, including both. I mean, at max, you both can go for 5.
We now load both in different times, so maximum of 3 GB and 10 GB.
Hello. So I'm Rohit, we are team Bhokali, and the project name is denoise. So the problem is that if someone has a lot of medical records, doctor might not review it because it's a lot to do this. And summarizing is also not the proper solution. So what we have built is, which is globally accepted because it's been reviewed and built by World Health Organization and also LH7 fire compliant, which is called International Patient Summary. So if you have a lot of document, what it will do, it's assume it as a backend engine. You will provide a lot of PDFs or images, and what is give output as a IPS. It's a JSON format by WHO. It can be used by anywhere, like in like a doc assist tool or anywhere. So yeah, so the thing is that it will save time. So the OCR is being used, passing medical record is used by EkaCare, and the thing is, the magic is happening behind the scene is the conversion of that smart report into IPS, into meaningful record. That's the thing. So the IPS look like this. So doctor just can see records like this and just go on. This is the record based on like 5 records, and each record contains around 10 pages. So,
sorry, so you're saying patient just uploads whatever they have?
so it can be integrated anywhere. The uploadation part is being done here. So the medical record look like this. So this is the thing which we have summarized all into the IPS, these first 4. So it is
It has to
easy
be
for...
a digital report, or I can like click stuff and put it also?
What?
It has to be a digital report, or it can be just, I can click stuff and put it
So the output of the OCR is given by the ECA Care.
Okay, so you're using that too.
That only. So they are giving the
formatting is what
formatting the smart record. Initially we were using the Mistral AI, but later on we got to know this is the better solution to integrate into the...
Is this a large use case in general? Like, why did you guys think that this is important?
Why? Like, if I go to the doctor and I say that these are the records of my... We have the data that not lot of doctors are raising the concerns, even though we have created the API into the ECA Care. And the main problem comes to it, even if I raise the content, there are a lot of medical records. How I will read that much of a record? It's better to view it in a very nice way, so that even the insurance company will also like review it in a very less time. If let's suppose... What? So something called IPS, International Patient Summary. They have a standard format. There are 4 fields: allergies, basic results, and that. Reading every document. So the part that the field goes into which section is being done by the AI. So the main thing is the JSON format by the IPS. So, yes.
3 of them are a doctor consultation, where one was on X date, then Y date, and Z date.
Mm-hmm.
Z is greater than Y is greater than X.
Mm-hmm.
Now, when you are doing IPS, how are you bringing that intelligence that the medicine written in the third one supersedes the medicine written in the...
Let's suppose hemoglobin is there, and you have...
How are you doing that intelligence?
So hemoglobin is there, 5 different time zone.
So you are arranging a time series.
Yeah, so because in IPS, the things which are in like same, let's say hemoglobin is there, same, it's come under the same section, so doctor can see the time date and the hemoglobin.
Just arranging it.
So
see, the need for a presentation layer is very, very real. See, including in their own PHR, like even let's say with ABDM, you're going to get records from all over different this ones. When you want to show it to a doctor, who's going to go and open each of these PDFs? Nobody's going to go do that, right? You need a nice presentation and a summarization. So the IPS is a very interesting approach to the problem.
Why the AI comes into the picture is just a characterization of that this field goes into which part of the IPS. Because IPS is a standard format, we can't tweak that, and we can't write to AI to give the... Less of the things is AI. Yeah.
I was of the view that IPS is good for only like primary care kind of scenarios, but that's not true.
What?
Primary care data ke liye it's...
like
primary care profile ke liye acha hai, but I don't know whether oncology or other things ke liye it will really work.
It's just for summarization of the patient thing. That's it. No.
IPS does it have
It's just there is a field that if you have something like this, it just show that this is the thing. Let's say you have a kind of allergy which is very severe. It go into a section that doctor will know. It have that allergy. That's it. Not beyond that.
Cool. Thanks, everyone. That's end of the pitches. Now we'll go for the judging part. Yeah. Same room.
Can I just say to everyone here, guys, you've all taken like 2 days to show us what you're capable of. Our assessment in 2 minutes is nowhere reflective of what you guys are doing. Please bear that, and whatever we say, please take it with a fistful of salt, not even a pinch. Thank you.
No one to tell you how good you are, okay? You are already good, okay? Thank you.
So your... Okay. Not the badges, but the... This is okay, right? Yeah, no, that's fine.
Or we'll come back here.
Yeah, you will come. just wait right now. They'll be coming for the decisions.
Okay, they're coming with a decision.
Yes. Guys, the judges will be coming with their decisions in like 5-10 minutes. So be here. And track 2, guys, you can collect your certificates over here. AKA and Scribe and EMR, guys. Both track winners will be announced in like 10 minutes. Sorry?
Yeah, from track 2.
Yeah, can you sort it? Everyone, wrap up your bags. We'll leave as soon as the winners are announced. Yeah, judges will come. Just Hi guys, so we have the results. Request everyone to come forward. Okay, वाला पहले. EMR. हाँ, मैं EMR से right. EMR.
I think they're watching. Yes.
Ready to announce.
Please keep that official Summit AI event because these guys will ask me. No, yeah, that will keep.
First, sir, एक का scribe वाला type. Scribe.
Has been quite a long sort of hours for us all. We have to quickly now announce this. Let's start with first the Scribe B2DD track, which is basically integration between Scribe and EMR. So the runners up for that track is 2Care. Yeah, Kiran, if you can. Maybe up on the stage. The first is? And the first one is Open Health Network, the first team that presented. They are not here. They have to go to catch their flight. They flew in from Kochi. But yeah, we'll take the money and have party. Now, the next track, which is again 10 teams, but very difficult to judge. That's why we have actually 4 awards there, not 3. And the third will be split between 2 teams. And those 2 teams are CuboCare and System Hang. Surbhi, yeah. And now the second one goes to CarePal. Rohit. And what about the first one? Any guesses? Nobody wants to guess. Nobody wants to even shout their own name. What did I hear? Gray hairs. I heard gray hair. Anybody else? No one else is confident. Okay, let's give it to grey hair, the first. Please come. Abhishek. Yeah, after this. Take a group picture. One picture with the judges, if all of us can just come on. Surabhi, please. Oh no. You are the sponsor. You are the. Internal teams. Any guesses? Okay, so let's give it to Bhokali.
Okay, so we have something for our judges as well. Yeah, who's first? Huh? Okay. Kiran, Dr. Sanjana, can you please? Okay. Thank you. Rohit, thank you so much. Anu, yeah, आप दे दो. Anubhav. Huh? Okay. Abhishek. Okay. Neha, can you please come and give few? We have something for Dipali as well. Dipali, thank you so much for all your help.
Thanks, everyone. I just want to shout out thanks a lot to all our partners, Ashoka University, Activate, Koita, and a lot of help also. High Table, Nelson has helped us with a lot of engagement, so thank you for that. And our partner who's helped us arrange the space, AWS, thanks a lot, Dipali. And again, shout out to Suresh, who's been here the whole day, helping us set up the whole room and the whole engagement here as well. Can we give a round of applause, please?
Requesting all the organizing team, mentors, super mentors to come on the stage and have a group picture, please. Mentors, super mentors, organizing team. Sir? Come. Neha, Trilok, come first. No? Vishwesh. Naman. You also, please. Yes. Yeah, yes, now. Fast.
Guys, we don't have time.
Come.
Yes. Come, closer.
Is anyone missing? तो नीचे आ जाओ भाई.
तुम कहाँ माइक गाना बजा?
Thank you.
Everyone come over. We'll have a group picture. All the teams here, please
All the
come
teams.
over.
Guys, just be on the seat. Come on the seat.
Alright, it was rocking.
Haskell, do this. Can you please do this?
सब चले गए क्या? Guys, we do have networking dinner after this, so please stay back. We'll be leaving to Maize and Malt, which is a few kilometers from here. 2 kilometers? 2 kilometers. Yeah?
Yes. Maze and just announce.
Huh?
Just announce. No, not on Discord. No, Discord is something. But
Yeah, I've told them. चलो ना फोटो लेना यार आ जाओ.
Come on stage, please, everyone. Sanika. Vicky.
यार मैं सबको बुला रहा हूँ.
I was standing behind her.
Sanika.
बिल्कुल.
ऋषभ.
अब आओ ना इधर आके आइए.
बैठ जाओ क्या?
You can also.
Sankalp sir. Sankalp.
Tell us when you
Can you guys also come? Please join. Vikalp sir, can you please join us? And all of everyone.
Suresh bro.
Surbi Vikas, please join us.
You are a part of it. What about Vishwas?
Selfie.
किसी ने नहीं किया.
कैसे कर दिया?
तुम्हारे लोग सर ने किया.
जो डालेगा नहीं, ये जो डालेगा वो थोड़ी करेगा. Guys, the dinner location is Maize and Malt. You can stay here and we can go all together. कितना?